Hey everybody, doing a weekend stream. I want to try and get WebRTC working. So we're going to need that for two reasons. One is I want to use it for a preview because I think it would be a really interesting way to preview the inputs in like a production window, and we can start working on the front end for it, but basically a production window where we could see the individual views. And I think WebRTC would be an interesting way to do that. We could make kind of individual peers or something for the channels, and you would be able to preview those, or we could just create one peer and then we swap what's going out to it as you signal the server which input you want to preview. I'm not entirely sure where I want to go with that yet, but that is one thing. So basically treating WebRTC as an output. The other thing that I want to try to do is WebRTC as an input, so that you could like just go to a browser page and do WebRTC, and then you'd end up in the feed, right? And then we could just switch between participants or do picture-in-picture, or however we wanted to signal things, right? And I mean, eventually I could see like maybe like a front end for this where you have a web UI where you could actually grab the individual inputs and resize them or something. But for now, I know almost nothing about the way WebRTC works. So I did find some examples of elements for GStreamer for WebRTC. So we're going to start with those, but I feel like we're probably going to need to do some research on the way WebRTC is actually implemented and some of those challenges and hurdles that we're going to have to kind of cross over. So I did manage to get this demo running. Yoda Droid, how's it going? So inside the GStreamer examples, there is a send and receive example that's written in Rust. And I was actually able to get this working. I guess I can demo that really quick, and then we'll have to figure out kind of where we go from there. Hope you're having a good weekend, Yoda. So let's cd into my code. Is my bot running? Okay. Bot is running. I was kind of going back over the stuff. Can you say something about how much effort it is to get the project up and running with like test streams? Streamed after more than a month. Wow, that's awesome. Welcome back. So finitely generated. Can you say something about how much effort it is to get the project up and running? So do you mean just... Okay, so if we go into the switcher, I'm gonna come down here too. Lots of terminals in there. Okay, so if we're just in here, you could just do a cargo build, right? Which is equivalent to me doing a cargo run, right? And we should probably maybe like document this API with some examples. And if anybody's like looking for a way to contribute, that would be like ridiculously beneficial, would be to have sort of a help documenting out all of this stuff. So give this a second to build. But, you know, we're doing a cargo run here, which is just a build and execute. But all you would really need to do is do a cargo build. It would generate the binary in target, you know, depending on whether you did a dash release, then you would end up in the release directory. But you would just end up with, do we have anything in here? Oh, wait, it's not in here. But you did just have the switcher thing there, right? So a build run, but then you need streams to send in and turn on off. Right. So you would need to, I need to try out Insomnia here too, but oh, why did you open up over there? There we go. So you would just need to come in here first and add a mixer. Let me close all this stuff. Sure. Save changes. Sure. Okay, so the first thing you need is a mixer, and that's basically just the thing that's taking the inputs and turning them into one or more outputs. And you just need to post a basic body. I don't think any of these are required. The name would be required. So once you have a mixer, then you can add an input. But an input doesn't have to be a stream. It can just be a video. So you could just test this with a video if you wanted to. That's the same thing we're doing here. And then as far as the outputs go, you can also do this. So I'll show you this. I don't know whether NVENC is going to work right now because I'm actually streaming with Software Encoder today. For whatever reason, when I went to go live, OBS decided it does not like my NVIDIA drivers. So that's where we're at. So I'm going to go ahead and delete all of this. The location also doesn't matter. We're just not going to save it. But you could submit auto. And if you do auto, what that's going to do is it's just going to open up. Oh, auto requires a location. We need to fix that. So that doesn't matter. We'll just send an empty one. But you'll see this just opens up a player locally. And then we could just send it a video, right? This is just a WebM file. And then it should start playing here. See? So you don't need like the whole setup that I have to like demo this stuff. You could just do it straight off your computer with no RTMP endpoints, you know, to stream to or anything like that. My demoing is just solely based off of like showing people that you could do all of that. Okay, so what we want to try and do today is introduce like a browser window. I mean, whether we'll get that far. The mixer is part of the GStreamer pipeline. So if we look at, I'm not running it. But so there's two elements that we're using. We are using a audio mixer, which has multiple input pads and one output pad. And then we are also using a compositor. And this is how we're mixing the video together and doing picture-in-picture and setting Z orders and things like that. So we're effectively just in Rust assembling a whole pipeline for this stuff. So now what we want to do is there is a WebRTC bin element. We want to start messing with this so that we can preview our streams, both the inputs and the output itself in WebRTC. And we also want to try to get WebRTC as an input. So I don't really know much about WebRTC. So there are a couple of terms that I'm familiar with, but I'm not entirely sure about how they work. So let's just do like a quick kind of research thing here. Well, I guess I can run the demo. So there's a couple of terms, WebRTC stun and turn. Like, I know turn is when it's we need to fix NAT issues, but we'll go through here and we'll read some of this. All right, so let's we back up. There's a GST examples directory, WebRTC. This is send and receive. I imagine this is probably where we're going to work out of today. Whether we get this built into our project is another question. I imagine we'll probably spend hours on just this. All right. So, oops. Let's just back up and let's just look at, because we're going to be looking at a lot of code. Examples, WebRTC, send, receive, GST, Rust. Okay. Okay. So there's a couple things that I did notice. There's a pure, we'll probably walk through the code a little bit here and try to figure out what it's doing. But it does supply, it looks like, a stun server that it's using a public one, and then it looks like a turn server here. Now I do know that this URL is a place that we can go to actually preview some stuff. So what is that? Web. Yeah, okay. So here's our demo. So this is like a little video player that'll pop up here in a second. But what we need is this peer ID. So if we do a cargo run, and then we pass our peer ID, I don't remember what it was, 6219, okay. Well, we should get That's loud. All right, I was not expecting that. Sorry. Let's see. So what that's actually doing now is it seems to be taking a local pipeline and pushing it as our feed. So let's find the sound. I know that that's coming from an audio test source. Hello, hacker man doing hacking hacker hack. How's it going, Preston? Okay, so it looks like we have this. I believe that has a volume on it. If it does not, we can send it through one, because that's not what I'm looking for. So audio test source, is there a volume? There is a volume. Okay, so we should be able to try this again and also pass volume equals 0. Usually a tongue twister, but I put in every programming stream I visit. So we are exploring WebRTC. We want to try to implement WebRTC so that we can do two things. We've got this like video switcher we're building that's going to run in the cloud. And we want to be able to preview the inputs that are coming into the switcher, as well as be able to preview the output. And we want to do that through WebRTC. The other thing that we want to be able to do is have somebody go to a browser and then have their stream injected into our RTMP feed. Okay, so I've now changed the volume, and hopefully that will work and not blast our ears out with a sine wave anymore. Oh. Because we have a different peer ID now. It's 3533. Could not set property volume. Why? Well, I mean, I suppose the other thing we could do is just remove it. I don't know why that wouldn't work. Why would you not be able to set the volume to 0? Oh, it keeps changing on us. All right, so I guess we need to understand a little bit about that too. Like, why does the peer ID change? There we go. There we go. Okay, so we could see what happened there was we were sending kind of the bouncing ball, right, to and no volume, a sine wave with the volume set to 0. We were sending that to the WebRTC peer here, and then this peer was capturing my webcam and my microphone and sending it back as an input, and we were running that through, I guess, a auto video. Yep, auto video sync. Okay, so this is basically where the input's coming back in on incoming decode bin stream. Perfect. So I guess we need to look at a couple of things. So one is, I think that we should probably back up for a second and figure out, just understand from a very, very preliminary concept how WebRTC works, either through walking through this, walking through the JavaScript on the browser side, or both, maybe combined with some like online documentation and tutorials. Because I know that there's a few pieces to it, right? So I know that we have the client-side JavaScript. I know we have stun and turn, and I know there's like a signaling WebSocket that they need to communicate with. So right now we're communicating with this one that whoever built this demo has set up and has been gracious enough to leave up for us. But I gather we're going to need to run our own. I think we can use public stun servers, if I recall. I think turn is the one that we want to run our own. So, is anybody here familiar with WebRTC? I guess that's a good starting point. All right, so maybe we should pair this with, I think I saw in the other directory back, JavaScript. Okay, so here it looks like we're loading up a WebRTC JavaScript file. Just creating a video. Okay, so this JavaScript, or this HTML file seems to be this here that we're looking at. So we're looking at the code that they have running. So is there a reason that we need to use use our own? I mean, eventually we're going to have to build our own, right? Okay, so they have like a default peer ID. Remember how we have this changing? So maybe if we, because it's saying to set this if we want to use a specific peer ID. So maybe we might want to run this locally so that we can just hard code the peer ID. And we'll just have to kind of figure out how to do that. Because that's going to be what's the hardest, is how do we negotiate those things? Oh, stun and turn, gonna give me PTSD. Yeah, so I don't know a whole lot about stun and turn, so we're gonna be figuring that out. So, but that seems to be all this is. It looks to be the JavaScript and HTML for this page, which is perfect. We'll try to use theirs as much as we can, but maybe we have to run our own locally. However, I have the feeling that we're going to have to communicate with a WebSocket on our side. So we're going to figure out whether we can either get whatever they're using to handle that, right? Because I know there's some sort of signaling that happens on the WebSocket. So we're going to have to figure out what that is and implement it on our end, or figure out what they are and use it. So where does WebRTC fit into the architecture of the switcher? Sure. So if we look at Excalidraw, the idea here, whoa. All right, why can't I scroll once that happens? That's annoying. All right, how do I center you? You zoom in, zoom out. No, no. Oh, space drag. There we go. Okay. So the idea here would be that we could have WebRTC here as an output, right? So this would effectively work as like a preview before it goes out to somewhere to be transcoded or something. However, I also think that it would be useful here. Okay. We'll point. I'll draw this out later. So I think it would also be useful if the switcher served up that page and we had like a little production area where you might be able to see the previews of these inputs, right? So we push each of those inputs out to either many peer IDs so that you could view all of them to see what's going on in each of them, or we just have one, and as you click to preview, you would be able to see that here. So that would be one use case. So that would be WebRTC as an output. However, the other thing that I'd like to do is not replace, but offer WebRTC as another option instead of this. So if you didn't want to run OBS and push RTMP and all of those things, you could theoretically just hit a browser URL and then be a potential input to this switcher. Nick Sative, how's it going? I need a project to start. I don't have my laptop and I didn't push the changes to my file sharing server project. What part of the stack do you want to work on, Nick Sative? Okay, so let's look at some stuff about WebRTC. I guess this one sounds good. This one also. Understanding WebRTC media connections. All right. And also, I think that there's a post somewhere in here that this like linked to that I didn't read. Here we go. Documentation. Perfect. Okay. So I think these are all good starting points. Now, I know WebRTC is like built off of, you know, all the other streaming protocols that exist, but I haven't done a deep dive into how it works. So we are going to learn this together, and here you get to watch me bang my head against the desk while I try and figure out something new. Well, I suppose this whole project has been that, hasn't it? All right, so late last year, let's see. Okay, so this is just talking about how to use WebRTC bin, which we kind of saw already, right? That's not the part we're concerned about. I think if we're going to like implement this and pull it in, we really need to understand how it's working. Okay, so here we go. So when our pipeline goes playing, it is a headbanger of a project indeed, yeah. We've learned a lot though. And it's, I mean, it's pretty cool that it's at where it's at, you know? All right, so when the pipeline goes into playing, the on negotiation is needed. Callback will be called. We will ask WebRTC bin to create an offer which will match the pipeline above. So I'm not entirely sure what it means by an offer. Is this basically saying, hey, we are potentially able to send you a feed? When it's created, okay. Okay, so this, maybe this isn't the starting point. Let's drag this way. because I think we kind of really need to understand what this like negotiation process looks like before we try to look at like what GStreamer is doing during that negotiation process. How did Dark Reader get turned off? Okay. Ooh, here we go. An introduction to WebRTC signaling. Perfect. All right, so there's something you need to know about me. When I get excited about something, I tend to get really excited. Okay. In case you didn't catch this from my previous blog post articles, WebRTC does not define a signaling protocol. It's not because the developers were lazy or simply forgot. You need signaling on another device before you can send media to it. Signaling was left out of WebRTC for some very good reasons. Different applications may prefer different protocols, so WebRTC working group did not want to lock it down to something that may turn out to be inadequate for all its uses. WebRTC runs in a web browser, and support for signaling would require the web pages would need to be stateful. This becomes problematic if signaling is lost each time a page is reloaded. Okay, I can get that. All right, so since signaling is required for call setup, WebRTC solutions must include a signaling server of some type. Okay. WebRTC requires that the server understands session description protocol, the same protocol that SIP uses. It's been a long time since I've done SIP. Okay, so don't think that this means that the WebRTC server automatically uses SIP for signaling. STP is a protocol unto itself and can be used by any signaling protocol to define, advertise. Okay. Tell me we don't have to go looking through docs for STP. Okay. Step by step. The mechanism used to create a session between two parties, let's use Andrew and Linda, is described in the specification of JavaScript Session Establishment Protocol. But that document is lengthy and somewhat involved. Here's a straightforward explanation that will provide you with enough information to be dangerous. Andrew creates an offer that contains his local session description protocol. Andrew attaches that offer to something known as an RTCP peer connection. Andrew sends his offer to the signaling server using WebSockets. WebSocket is a protocol that provides full duplex communication channel over a network connection. WebRTC standardized on WebSocket as the way to send information from a web. Okay, so let's see. So he sends his offer through the WebSocket. So we know stun, turn, and WebSocket, right? So those seem like the three things we need to communicate here. So the offer is sent on the WebSocket. Sewage treatment plan. All right, so then Linda receives the offer over the WebSocket. Linda creates an answer containing her own local SDP. Linda attaches her answer along with Andrew's offer to her own RTC peer connection. Linda returns her answer to the signaling server using a WebSocket. Okay. Okay. That makes sense. So I create an offer. I send it over WebSocket to some signaling server. You receive my offer. Then you bundle that with your own offer, attach it to your connection, and then send all of that over the session description protocol. Okay. I'm saving explanations of ice, stun, and turn. So these are the other things I've seen mentioned with this. Clients use WebSocket to communicate to a signaling server and vice versa. Okay. So, here we go. Oh, it's the same thing. Okay. So now we can look at, we understand kind of what's happening over the WebSocket. Now let's try to understand what all of these other things, their roles. Okay. Left out quite a few details, but for the most part, those refinements were very geeky and unnecessary to the point I want to express, okay? How do you deal with the fact that most endpoints have been assigned a private IP address behind some form of firewall? Before I answer that question, allow me to define a few terms. This will be pretty basic stuff for you networking types, but I want to make sure that we're all on the same page. It would be easy to get far more complicated than what I am about to. Okay, let's see. I think we all understand the difference between a public and private address. Is everybody here familiar with what network address translation is? Okay, so symmetric NAT, we'll go into that. So not only translates the IP address from private to public and vice versa, it also translates ports. There are various rules as to how that translation and mapping occurs, but it's safe to say that with symmetric NAT, you should never expect that IP address port of the source is what the destination will be. Okay. Now let's return to our problem. How do two WebRTC clients communicate with each other? Let me turn this down a little. All right, how do two WebRTC clients communicate with each other when there's a good chance that neither one of them has an IP address and port that the other can directly send to? All right, so this is where Interactive Connectivity Establishment, ICE, comes in. ICE is a framework that allows WebRTC to overcome the complexities of real-world networking. It's ICE's job to find the best path to connect peers. It may be able to do that with a direct connection between the clients, but it also works for clients where a direct connection is not possible. In the case of asymmetric NAT, ICE will use a stun server, Session Traversal Utilities for NAT server. A stun server allows clients to discover their public IP address and the type of NAT they are behind. This information is used to establish the media connection. Okay. In most cases, stun server is only used during the connection setup, and once that session has been established, media will flow directly between clients. Okay. So it's basically just asking the stun server what my public IP address is, and am I behind a NAT, and if so, what type of NAT? Let's read the RFCs. Let's implement the RFCs. I actually do like doing that. I don't know why. I get nerd sniped a lot. I actually like reading RFCs and trying to implement them. Okay, so if a stun server cannot establish the connection, ICE can turn, pardon the pun, traversal using relay NAT is an extension to stun that allows media traversal over a NAT that does not do the consistent hole punch required by stun traffic. Turn servers are often used in the case of symmetric NAT. Okay. So what this is saying is basically we're going to communicate with stun. We're going to say, hey, what's my public IP address? Am I behind a NAT? Can I directly connect to a client? If I can directly connect to a client, I do. If I can't, then I get routed through a turn server that proxies the connection. That's what this sounds like. So unlike stun, a turn server remains in the media path after the connection has been established. That is why the term relay is used to define turn. Okay. Clearly, not having to use turn is desirable, but not always possible. Every WebRTC solution must be prepared to support both service types. Okay. This is just asking like where you find stun servers, but like we could run our own too, right? Email RFC compliant regex. Okay, so this makes sense. So I guess what I'm trying to understand here is, so this diagram is missing our WebSocket, right? So I could be completely wrong here, but let's walk through what I think happens. I think all of this happens before the offer thing we just read about. It sounds like this is used to establish the connections between the two clients. Well, no, because that would be... Okay, so we understand what's happening for these two things to make a connection between each other. However, there is something that's happening between the WebSocket. So at what point does the WebSocket thing happen? All right, we don't need that one anymore because we kind of get that. So let's look at the JavaScript, maybe, because I think that all of this is going to be handled behind the scenes in the GStreamer thing. I think maybe if we look at the JavaScript. Yeah, so the WebSocket is outside of here, right? So that's sort of what I'm trying to figure out. The WebSocket exists on like some public site over here. So we got to figure out like what order these things take place in. These two articles did a good job of kind of explaining each workflow, but it sort of doesn't fill the gap of how that works. Oh, here's like writing your first WebRTC application. All right, I take it back. Andrew, I take it back. Yeah, so they refer to the WebSocket as signaling. So my guess is, if I had to guess here, it would be that both maintain a connection to the WebSocket, and that they do like an offer exchange. And if the offer is exchanged, then we end up forwarding our connection information over to the other side. But I could be totally wrong here. I don't know anything about this. That's just my assumption of how you might negotiate that. Because how would you discover that other client over there, right? Turn and stun, neither one of them is discovery. So we'd have to figure out how to talk to there. So WordPress. Okay. Let's see. Beginning of the beginning, HTML. We just want to get to the good stuff. Okay. So here's the signaling server. It needs to do two basic things: exchange the metadata necessary to perform the signaling. This includes some form of addressing and SDP, and deal with network address translation. Okay. Oh, that they actually use WordPress's website. Yeah. Okay, so this is a very short article. I'm not sure they explained anything. Okay. Where's part 2? Part 2. Part 2. All right, I'm not too worried about API differences. I just want to know. I just want to see how everything fits in. Okay, so here we go. The goal of WebRTC is to enable multimedia calls to and from web browsers without the need for plugins such as Flash. Okay. In all WebRTC solutions, there will be a calling party and a called party. While much of what each half does is identical, there are some very important differences. A common flow that both caller and called will follow goes like this. Connect users by way of signaling server. This can be accomplished in any number of ways, but the easiest method is for both users to visit the same website and connect via a shared signaling server. Users exchange some sort of name or token that allows for the unique identification of the session. This shared token might be a room number or conversation ID. The most common way for WebRTC clients to connect to a signaling server is a WebSocket API. Okay. So once the clients have a shared token to identify their conversation, they can start exchanging signaling messages through the WebSocket connection established above. Since WebRTC does not specify any specific signaling protocol, it is up to the solution developer to come up with one of his or her own. Okay, so we could do something really basic here, right? We could, in theory, just allow everything to pass or look for a username and password or something. Okay, so each side will exchange information about its networks and how it can be contacted. This step is often referred to as finding candidates, and its purpose is to allow web browsers to exchange the network information required to send direct media, since most clients will use private IP addresses in some form of NAT. Okay. No need. What are we referring to, Vega? Okay. No netties are being coobered today. I figured that I would try to learn something completely new that I know nothing about. So here we are learning WebRTC and trying to see if we can implement it. Okay, so WebRTC calls this process of using stun and turn servers the interactive connectivity, okay? Once clients know how to communicate with each other, they need to agree upon the type and format of the media. This is accomplished with something called JSEP, okay? Oh, interesting. So we can negotiate resolution, bitrate, and frame size, or frame rate here. Okay. I like it. Okay, so this is RTC peer connection API is where the real work of establishing a peer-to-peer connection between the two web browsers occurs. It deals with the ICE handler media streams. Okay. We create an RTC peer connection. Okay, so this is used on both sides. So for the calling party, we register an on-ICE candidate handler. The on-ICE candidate handler sends ICE candidates to the caller's peer using the signaling channel. Okay, yeah. So this sounds like we go to the WebSocket and say, hey, I want to communicate with this party. And the WebSocket forwards that to the other side. The on-stream handler displays video stream once it's received from the called party. A message handler is used to process messages received from the called party. For example, if the message contained an RTC ICE candidate, it would be added to the MyPeer connection objects using add ICE candidate method. If the message contained an RTC session description object, it would be added to the MyPeer function. Get user media captures the local media stream, which can then be displayed on the local page. That stream must then be added to MyPeer connection. Okay, so for the called party, the steps for the called party are very similar to the caller's flow, with the exception that the called party responds with an answer to the caller's offer. So they register the same ICE candidate handler. Register an on-stream handler. The on-stream handler displays the video stream once it's received from the calling party. A message handler is used to process messages received from the caller. For example, if the message contained an ICE candidate, it would add... Okay, we already read that. Okay, so I think that I have a rough understanding of how this is all working. I think. So, is there anybody not with me? This sounds like we communicate over a WebSocket to begin with. That's sort of like our shared location that we go tell, hey, I want to connect to this room or whatever. And then that negotiates across the WebSocket to both sides. And then we start the actual client connectivity using stun and turn. That's what it sounds like. Okay, so let's back up through here with the GStreamer stuff where we can kind of understand it a little bit better. So this is just establishing a pipeline. So this is grabbing our local video source, stuffing it through a queue, encoding the video with VP8. I don't know what RTP VP8 pay is. Let's see. GST inspect RTP VP8 pay. RTP VP8 payloader. So that's interesting. I don't know what a payloader is, but okay, so we're just setting some properties here, and then we're forwarding that to the WebRTC bin. Okay. But I don't see how this is like configuring anything. Oh, that's why we have callbacks. Okay. So we're parsing that, we're getting our pipeline. Okay, so now when the pipeline goes into a playing state, this is on the on negotiation needed callback. And this is where it wants us to create our offer. Okay, so this is what's going to be sent over the WebSocket. I don't know what this GST promise is, but okay. When WebRTC bin has created the offer, it will call on offer created. Okay. All right, so this is the offer itself saying that we can edit it. Okay, so it looks like we have to handle the whole flow here. So we ask it to create an offer, right? And we'll ask WebRTC bin to create an offer, which will match the pipeline above. Okay, so this is us getting signaled like, hey, the connectivity's here. You need to create an offer. We ask for an offer. When GStreamer creates the offer, it looks like we are just sending it over SDP. All right, similarly, when we have the SDP answer from the remote, we must call set remote description. Okay, so this answer isn't our answer, this is theirs. Okay, so ice handling is very similar when okay, so this is all local. This is all local. All right, so ice handling is very similar. When the on ice candidate signal is emitted, we get a local ice candidate, which we must send to the remote. When we have an ice candidate from the remote, we must call add ice candidate on WebRTC bin. There's just one piece left now, handling incoming streams that aren't sent by the remote. Wait a second. Ice handling is very similar. When we get an on ice candidate, which is another caller calling us, we get a local ice candidate, which must send to the remote. When we have an ice candidate from the remote, we must call add ice candidate. Okay. So handling incoming streams that aren't sent by the remote. I don't necessarily know what that means. Is this like it didn't go through the signaling, it tried to connect to us directly? For that, we have on incoming stream attached to the pad added signal. Okay, so this is taking the stream. Oh, is this the actual media? Is that what this is? Because, I mean, this is the only point at which we're starting to handle things, right? So here, we're taking the stream, sending it through a queue, decoding the VP8 video. We're converting it to meet whatever capabilities we've set, and then sending it to auto video sync. Okay. I mean, why not? All right, I think I have a rough understanding of how this works. So there's a couple things we want to do. Maybe we should leave their example before we try to like pull this into this switcher that we're trying to build. One thing that I would like to figure out is how can we just get them to connect, right? Because right now we have the problem when I run this, right? I have to supply a peer ID. I don't want to supply a peer ID. Ooh. So here's something like I used Friday for getting Aaron on the stream. I really like OBS Ninja for some stuff. So this probably is not going to let me use my camera. Let's see whether I lock up my camera. Look at that. It allows me to use my camera for both OBS and here. So, what I want to see is can I connect to this? Let's go here and let's do no audio. All right. It's weird in how low latency it is. That's because it's using WebRTC, right? I mean, as long as you don't have to go through a turn server, right? So the problem that we have with like latency in live streaming, even RTMP is really low latency. The issue is that what you're actually consuming right now is not RTMP, right? RTMP hits their servers, they transcode it, transmux it, transize it, all of that good stuff, and then deliver it out over a CDN so that you can get adaptive bitrate, and because it scales to a lot more viewers, right? So that's where all of the latency is introduced. If we just pushed RTMP from one place to another, we would have like a lot less latency. Right, and then buffering, yeah. So, okay, so I want to know how do I, so I know that there's a WebSocket here, right? Began, welcome. Thanks so much for the raid. So we just went through like a few minutes of discovery. We're learning a little bit about how WebRTC works because we want to steal it. It's all ours. Nobody else can use it after that. So we want to use it for a couple of things on the switcher. One is to preview the inputs and I suppose the output. The other is we want people to like go to a web page like this OBS Ninja, and then we want to be able to connect our switcher and pull that feed and inject it into our stream. So my latency is 2.2 seconds and my buffering size is about 1.7 seconds. What are you referring to? Are you referring to WebRTC, or are you talking about the player for like Twitch or something? You streamed pretty late today, didn't you, Beacon? Okay, so here's what I want to know. So they have peer ID here, and it sounded like we could make up whatever we wanted. Oh wait, no, this is JavaScript. We don't care about the JavaScript. Go away. So here's our peer ID. It's assuming that we need a U32. But we know that OBS Ninja has like... We know that OBS Ninja has this weird thing, so that's not a U32. So, what can we do here? I want to know where this is used. Like, can we... Okay, so this is saying join the given session. So I wonder if we change this from U32 to a string, whether we can get it to connect to OBS. Or to OBS Ninja, rather. Okay, so all the raiders are awfully quiet today. So here's what we're going to do. I want to change peer ID. And we're going to make that a string instead. And we're going to see whether we can still get this to compile. Cargo build. Okay, so this is still yelling at me. Why? Value used here after partial move. Move occurs because the value has a type string which does not implement the copy trait. Borrow this field in the pattern to avoid moving. Alright, so 669. Alright, so this is... I always forget how to do this. Is it just... So here, I know I can do like an as ref or something. I know I've done this before. Oh wait, no, it's here, right? This is where I want it. And the reason for this is that when we do this sum, we actually pull this value out of this option. Okay, so now we should be able to, in theory, be able to pass a string here instead of an integer. And then we also need to figure out where the WebSocket is for OBS Ninja. So in order to do that, we are going to go look for OBS Ninja's GitHub. Okay. Main.js. Where are you, WebSocket? I know I've looked at this code in the past. WebRTC+GStreamer? No. Let's see. Let's search for WSS. Where are you? Okay. We will find you. So this is all their turn server configuration, but that's not what we're not what we're looking for. I mean, can we look at turn off audio. All right. Here we go. So okay. And so I know that we saw also in here that there was like a server flag. Like an argument for the WebSocket. Yeah, so here. So I think that we should be able to do a cargo run -- server equals this. And then we should be able to say our peer ID equals this. I hope. I don't know. We could break some stuff here. Okay, so it says we're registering, but I don't think that's what we wanted. Let's do a room. Right, because we're also trying to send data. So let's do a group chat. Testing. Already claimed. Okay. Tideman, thanks so much for the follow. All right, so let's pick WebRTC hacking. There we go. So I don't think it's a room name that we need. I mean, we could try that. WebRTC hacking. I don't see anything showing up here. So that's not what we want. Yeah, I'm not entirely sure how all of the room stuff works. I mean, it appears that it's connecting to OBS Ninja, right? So it must be our peer ID that we've got wrong. Let's see if we can look through the code a little bit and see how they're handling things, right? Because that would be ideal. I would, you know, we can build our own thing, but it would be really cool if we could get our WebRTC logic to connect to OBS Ninja. And maybe we should back up from this and do that later. That's probably not as important. It just seemed like a fun thing to try. So I want to know, like, how's it? Okay, so we know that a room name comes, so let's search for room. What's it doing here? Jump to room. Okay, that's not what let's go to the beginning. Okay. Room. Alright, so this is something to do with a session password. This is just a bitrate for the room. Like, what are you doing with the room name to get me to join? That's what I want to know. Alright, so this is all password stuff. Oh. You know what this is probably doing? Remember we talked about all of the negotiation, the signaling, that there's nothing really defined for the way that that part of it must work? I'm willing to bet that there's some logic that they're doing over their own WebSocket connection to identify the room and things like that. Right? They're probably sending some sort of information about like the room ID and password and things like that in order to like forward that over the WebSocket. So where is their logic to connect to the WebSocket? That's what I'm interested in. Okay, so this is sending messages over the room. So this is like how they're signaling each of the individual clients. We're not so interested in how they're publishing the screen or the webcam. But like, I'd much rather like allow somebody else to focus on like this side of things, and then we focus on, you know, how do we get this into our mixer? All right, here we go. Join room. Session join room. Then Play handles the group room mechanics here. So I'm guessing that this opens up a video player for this room. All right, join room. Show me. Wow, this is that Dark Reader? Okay, what are we doing? This is just calling session join room. That's the one I want, is session join room. All right, let's search. Join room. Interesting. So we don't even see, is that something that's just part of like the WebRTC spec? We're gonna have to discover that a little bit. Maybe we should come back to this. Let's try and get this working in the switcher. Let's focus. Because I think we're going to have to implement the WebSocket side of things, aren't we? I think in the examples directory, I do think that there is... yeah. Okay, so here's our signaling, right? So this is what they are using for all of their the signaling side of things. Why does Bailey's have to taste so good? Okay, so this is what they're using behind the scenes for their signaling. So we're going to have to implement all of this, or at least a very, very basic version of it. Okay, so here we're just creating a WebSocket, or just a web server that's serving the WebSockets. We're going to have to do the same thing. I don't know what they're doing with all these certifications, though. All right, so where did we notice the client connect? Okay, so here's hello peer. Okay, so they basically have the peer come in and say hello. All right, and then there's a UID. Okay, so it looks like it's hello and then a space and then whatever their ID is what this basically sounds like. Okay. And then it looks like it responds back with hello. Okay. Connection handler. What's calling connection handler? Okay, so every connection comes into this. This calls the connection handler. Connection handler always registers the peer? Wait a second. Where's the peer ID coming from? Oh, okay. Here we go. So it calls hello peer first. That checks for the hello space, the peer ID, returns back the peer ID, which then calls the connection handler, which has the peer ID in it. I don't know what this message ping thing is. in a session or room, message must be relayed. Okay, so there's room commands. Interesting, interesting, interesting. Okay, so there's something that it looks like. Hold on. So if it's not none, this is where we're deciding, okay, I'm in a session. So we need to route. Okay. So if our status is just session, where's this message going? Self peers other ID. Where's UID coming from? Okay, wait. Oh, okay. All right. This is making more sense. Huh. Oh, I turned off my alerts. Didn't I? No, I didn't. Why am I not hearing my own alerts? Well, thank you so much, Tater Panky, for the follow. I don't know why I'm not getting alerts in my ear. Okay, so what this seems like it's doing is first it checks to see whether we're like, if our status is none, then we're not connected to anything. So if our status is session, then what it tries to do is it tries to take our peer ID that came into this function, and then it tries to go look up in the peers. So there's this sessions hash map, it looks like. So it's going in there with our peer ID, grabbing the peer of ours. Who are we connected to? Who are we talking to? And then it's sending this message to them. It's basically grabbing the WebSocket from peers there. Okay. All right. That makes sense. If we are not in a session, then we must be in a room. And so, is this a loop? Oh, while true. So we keep doing this until we break. So all right, so this is just checking for the individual message types. Like, give me a list of peers, send messages. Okay. And here we're requesting a session with a specific peer. Okay. Okay. So this makes sense. Okay. I mean, we've got some additional handling and stuff in here, but I think all of this makes sense. And I don't know whether we necessarily need all of this yet. So we've got a couple of options here. One is we start trying to pull in the WebSocket logic into the switcher, both as sending data out, as well as receiving data in. Or we can start implementing this WebSocket side of things and see what we can do for handling all of this. And I guess serving up some HTML and stuff like that, because the other thing that we could do is like this whole logic here. Like we don't need all of this. So, all right, I'm going to use the restroom real quick, and I will be right back, and then we can start playing with one or both of these challenges here. I think a WebRTC input and output would probably be a cool thing to do first, maybe. And we'll just get it connecting to here. All right, be right back. All right. I think I'm going to leave this for now because there's like something already existing, and maybe we'll start trying to pull in some of their logic here for WebRTC. Because I think we could probably do that fairly quickly. Cillian, thanks so much for the follow. So we can see like here, the pipeline is fairly straightforward, right? We're going to need to handle some callbacks. However, it should be pretty straightforward. Why do I have the feeling like this is spam? Oh, is it just a song to listen to? Okay, I've got them both up. We'll listen to them. It's always hard because you never know, like people will come in and they'll spam links and somebody's talking bad about you on this channel. Click this link. Okay. So, we're going to have a few things we're going to have to set though, which is like the stun server and the turn server. So that is going to be interesting though, because currently, inside of our project, our inputs only have like a location property on them. So we're gonna have to figure out how to pass that data in. Shoot. No problem, no problem. So, let's back out of here really quick and let's go to our project, right? So here's my concern right now. So in our HTTP logic, let's look at inputs first, right? I mean, output's going to be the same problem. So right now we have sort of this generic create request, right? And so right now we only have like an input type and a location, but we do have an issue because on our create request, right, we have this like warp JSON handler here that's going to try to convert the JSON input to this type. So now we have additional parameters though, right? Because we need to be able to tell the input where to find its WebSocket, where to find the stun and turn servers. So this is actually going to require some refactoring of the project itself, which I'm not entirely sure how we're going to solve yet. Because now we basically need to create like different types here based on a parameter. Like if they tell me it's this input type, then so I'm trying to remember where this comes in. Okay, so I know we have these. Is it in filters or handlers? Okay, yeah. So here's where.
Tonight's performance features Nathan and Ava. Local sibling duo Nathan and Ava got their start performing covers online to their thriving YouTube fan base.
All right, what's the other one? Wait, is it the same one? Oh, it's the same one. Okay. So one thing we could do here is we could update our route. So this create request is happening. And the result of this function is what's actually being passed in to our final mixer create. So what did that look like? A from JSON body. So I guess one thought here is that we could not do a create request from JSON body. We could do an input from JSON body, right? So, so we did something like a input from JSON body. Then our enum could look at something in the request, maybe? Crap. It's just a thought. Well, so mixers, isn't it? So input add. Here we go. So in theory, we could have a type here as well, right? And that would determine what type we need to be able to go from here. Or I don't know how to look at the not headers, but let's look at Postman really quick and we'll see. Like, so we need a way of being able to say, Eric, thanks so much for the follow. So we need to be a way of being able to say that. So we have this input type here, but we don't have access to this yet, right? And I don't think we can read the body twice. Hey, JT. Yeah, I don't think there's a way that we can read the body twice. If we could, then we could just parse this out and then look at what this is. So our options would be like type equals, right, URI, maybe, right? Or we could do, URI. I don't like either of those. I would really prefer to have just JSON here that we could look at. Yes, doing JSON with Rust. So the actual effort that we're trying to do today is actually do WebRTC. We want to be able to preview inputs and outputs using WebRTC, and we also want to be able to use WebRTC as an input. So, but in thinking about our goal here, there is an issue with the way our inputs are created. Right now, they're very generic because so far our inputs and outputs really have only needed like one parameter, a URL. However, now we're encoder settings and things like that, which are different between them. So now we get into a situation where really we need that's like, what framework are you using going standard lib for what? For the JSON stuff? Oh yeah, the it's just auto mod. I'm slowly adding terms. So yeah, so most of this is using Serde. But yeah, so our issue right now is like this generic create input request, and we're gonna have the same problem for outputs. So what we need now is a way of being able to have multiple options here. And ideally, I would really love to be able to just parse the JSON enough to be able to find one parameter in it and then parse it in something else. Yeah, Serde and Warp have like absolutely destroyed my compile time. So let's look. Warp parse response body twice. Like, can we do that? Rust. Yeah, I mean, it's super performant, right? Oh, so this is not what I wanted. Well, let's just look up this logic, right? So from there we go. So we are calling warp body JSON. So we might be able to store that, right? Wait a second. Found any nice documentation for WebRTC? Stuff has been a bit sparse from what I could find. Yeah, according to Bo, did we leave up the page for it? Stun, turn, ice, web. Yeah, here we go. So these articles actually were really helpful. So this one was on how signaling is done over WebRTC. And then this one was sort of explaining the flow of like stun and turn and things like that. And that gave us a general idea of how all of this stuff works. So I've got a basic understanding of how the role's played. And it turns out that the signaling side of things, the WebRTC side of things, we get to just make up our own protocol. So we're going to do that, but I guess first we have to figure out how in the crap we're going to refactor this project to do this. So let's go to docs.rs and look for warp. And here I was thinking we would spend most of our time on the WebRTC stuff. Okay, so we're looking for body JSON. All right, what's this returning back? It returns back a filter that matches any request and extracts a future of a JSON decoded body. Oh, so can we do custom logic here? Now I'm curious, can we handle that? Because if we could inject ourselves in here, right? If this is a future, then we should be able to do... No. Is it here? Map? Yeah. So... I'm just thinking here. Because really, we want access to that JSON, right? Because what I really want to do is I want to return back just a generic input. And let's just make sure that this line of thinking is going to follow through. So we're matching on a filter here, right? So we have like input add, right? That's setting up our routes. So here we're just matching on this format, mixer string input. We're checking that it's a post. We're calling this function, which is going to end up creating a parameter to here, right? And we can see that here, right? So this comes in as mixer name. It's the first parameter, right? This creates the second parameter, which is this input, right? And then we have this with mixers, which is creating our this one here. So we need to figure out whether it is possible that maybe whatever method we're using here, we could return back a input mod, one of these enums. And if we can do that, then that would allow us to also try to override, where are you? From JSON. No, where are you implemented? Here. So that would allow us to basically return back a input here, this enum, right? So that would be ideal. But before we can do that, we need to try and see what happens inside of here. So it looks like there's like simple map.
Good day to you, madam.
Okay, so I don't know whether, is this coming back as part of the response? Is that what it's expecting of us? Hello, I'm new to software development. Do you think it's worth learning design patterns? Keep up the good work. Yeah, I mean, design patterns can help. I mean, you don't have to necessarily like be super strict on them, but I think understanding design patterns and things, you'll commonly see them reused, right? And I think the more you study those things, you're just adding tools to your toolbox and kind of understanding how things are abstracted. I mean, if you're in your early phases, I mean, I wouldn't get too hung up on design patterns. I would spend more time trying to learn syntax, writing idiomatic code, things like that, and then you'll evolve into organizing that based on design patterns. But if you try to think about too many things at one time, then it starts getting really overwhelming. In the early days, just write code, learn from stuff, understand how files work, networks work, all of those things. I started to learn Rust yesterday after you shared some resources, but it seems really hard to me. Is it normal? Is learning curve hard? Yes. I will say that it took me longer to get to where I'm at than I thought it would, and I still feel very much like a beginner. So it's probably one of the more challenging languages I've learned. I mean, the basics of it, right? Like the basic syntax of things, that was pretty straightforward. Learning idioms, adding to it. But once you start getting into some of the macros and some of the stuff where I run into ownership issues and lifetimes, and I'm trying to think of some of the other stuff. Some of the traits that exist for different things that I'm not aware of. And Okay, I'm going to implement this because I want to see what happens. So this looks like it's just still chaining things together. So can I do a map here? Dot map. I don't know. We'll call it B. And this is hash map. Right? Hash map string string. Hash map string string. Oh, wait a second. Oh, this isn't good. This isn't going to do what I think it's going to do. It's not going to do what I think it does. I mean, we're going to use it anyway just because I want to understand it a little bit. But I think, if I'm right, what's going to happen is it's actually going to parse the JSON body into this. Okay, so that's not going to do what we want. What about Go? Is it easier? Thanks for the answering the question. Go was significantly easier for me to learn. I agree that Go is easy to start with and quite easy to understand long term. It won't do many of the things that Rust excels at, but for network services without hard latency requirements. Yeah. I mean, if you're trying to write API servers and like CLI tools and stuff like that, like you're going to be super productive in Go. It's going to be close enough performance for you. You know, you won't have any issues. But, you know, I value learning languages of different types, you know. I just think it's really good for people to learn. Okay, CA, you were reading Go in Action during the MEEP days? That's awesome. It changed a lot, many times. The things you learn in authoring a book, it goes out for tech review. And people kick the crap out of it. So you rewrite so much of the book to make those people happy. And then it goes out for a second technical review. And those people make complaints and basically suggests that you write it another way, which so happens to be the way you wrote it the first time that the first round of technical reviewers didn't like. Okay, so I need to write a Go or Rust. I'm going to use both personally. I like them both for different reasons. I'm more productive in different ones for different reasons. So yeah, I mean, so I need to figure out how we interact with the body. Yeah, so, So I can't really speak to Elixir much because I've never used Elixir, not even a little. Okay, so let's see. Rust, warp, dynamic. Okay, what am I want to look for here? Dynamic, JSON bodies. All right, so let's look at this a little bit. But yeah, so like doing this type of stuff is... Cruel Nerd, thanks for the follow. Comrade Weasel, also thanks for the follow. All right, so we need to figure out how to do dynamic stuff with this because I don't know what the type's going to be. I don't know what the type's going to be. You're a beginner in programming? Well, welcome. We'll try our best to help describe things. Okay, so filters parse the request and match against a route we created. So when you start the server, I think we need to. It's going to be some form of like filter chaining, where we switch those up based on something. We're just not going to be able to do it from the body. What can I recommend you? Do you mean as far as like a programming language to start with? I mean, there's a lot of code.org. Code.org has a lot of cool stuff. Khan Academy has like a programming. Go away. I just want a link. Learners. Courses. Wow, they've changed a lot since I've been in here. Where are you? Computer programming. They've got some stuff and you can play around with it in the browser. And it walks you through some kind of front end and JavaScript and things like that. Those might be good places to start. It's been a long time since I started and I had to learn a lot on my own. So I don't know of like all of the places that are best for super beginners, but I know of at least those two places. Okay, so now we add a new route and call the method you just created for it. Since you can expect a JSON for this, you should create a little JSON body helper function to extract the item out of the body of the HTTP request. In addition, we need to pass the store down. Okay, so this is exactly what we're doing. Best programming language for coding in backend. Well, backend is a very, very broad category. So it's going to really depend on what types of things that you are wanting to write backend stuff in. You know, my personal favorites are Go and Rust, but you know, there's a lot of backend stuff that's done in Java and Ruby and Python, and all of those are used Elixir, that are used in like big websites. So this is the same thing that we're creating. I know that this is the method we need to override, right? And doesn't really care what it is. It's just going to use it as a parameter into our ultimate thing. So I just need to figure out how that I'm going to replace this method with something that I can inspect the JSON body with. I effectively want to parse it twice. So I wonder if there's a way in Warp for me to just get the body. I mean, the only other way around this would be to find a way to look at URL parameters, right? I really don't want to do that, though. I just don't think it makes for a very good API. All right, so here's examples. All right, so query string, this is like a fallback for us, but ideally we want something different. Oh, there's some WebSocket logic in here. We're gonna need that too. Okay, so this looks like it's passing in a hash map. Wait, what is this? Oh, it's mapping the result of this. So this hash map is coming in. It's looking for the key. Okay, so this is the final thing that's doing something with that. but this is just passing in the query string. Okay. But this function, unless we do a map on it, that's not going to work. M. Dembski, thanks so much for the raid. Let's give Matt Dembski here a shout out. If you're not already following him, you definitely should. Especially we were just chatting about Go a little bit here. Matthew works on the Go compiler team at Google and is always doing like bug fixing and things like that on his stream with the Go compiler. So if you're not already following, you should definitely go follow. So we are playing with some Rust here. Well, a little bit of WebRTC and some Rust. So we started with investigating using WebRTC through GStreamer. We were able to use some demo code and things like that and figure it out for our RTMP switcher. And now we're trying to like bring that into the switcher and having some problems with Rust. So if you are new to the channel, what we've been working on is basically a switcher, like a virtual video switcher that we will be able to like switch between live video streamers and videos and be able to push those out to Twitch and YouTube, basically creating a linear feed out while we switch between these things, fall back to videos, do picture in picture, and all of that will be controllable through an HTTP API. If you're not familiar with kind of how video streaming works, I'm happy to do a walkthrough. I know I've done it a few times, so I'll spare everybody listening to it again if you've already heard it a few times. But if anybody needs kind of a crash course on how that works, I am happy to do that. So what we are working on today effectively is we want to create a web UI here where we can use WebRTC to preview what's on each of these inputs and potentially this output to preview it. The other thing we want to be able to do is create a WebRTC input over here so that you could just go share your camera or screen using WebRTC, and the switcher would be able to connect as a peer and then mix that into the video feed that ultimately goes out. I wonder why are the alerts coming up on the screen for followers? Okay. So the one thing that we're trying to figure out now is, I guess let me back out of here, is in order to make all of this happen, up until now, we've had one type of input. Okay, so the zombie comes up, we just don't hear it. So I wonder why we don't hear it. Okay, that's coming from the browser. Oh, interesting. No text either. Where is it? I mean, it's over there. I refreshed it too. Maybe there's an issue with Streamlabs or something. Oh, this is Bartholomew. I got tired of people trying to pronounce the stupid name. Yeah, the internet is hard too. Like, I always find it hard when I want to shout people out or do stuff, right? Like, M. Dembski here, right? Like, I know his name is Matthew Dembski, right? But if I call him by his full name, none of you in the channel know who I'm talking about, so I refer to him as his username, right? And then there's the pronunciation issues and stuff like that too. Put your money on me. Thanks for the follow. Dazzer, Unix, thanks for the follows. So yeah, so our issue right now is that we currently have one type of input request object, which just takes a type and a location. But now introducing things like WebRTC, both on the input and output side, now we have sort of this issue with the fact that we could have different JSON based on whether or not we have a certain type. So we could try to figure out, well, so we're trying to figure out like, how do we do dynamic handling this? Like, can I peek at the JSON result or read the body twice, which is not ideal, to figure out what type this is? Either that or we have to use a URL parameter for it, which it doesn't look like we have access to. We'd have to figure out how to forward in that. I guess suppose the other option is we could have something like this where we say parameters or options or something, right? And go-ism slipping out there, where we could just do string here, and then like maybe it's just a hash map of parameters. I tried getting WebRTC working in Jupyter Notebooks recently. It's amazing how we're always doing the same thing. Oh, you were doing WebRTC too? Yeah. Cbro was also doing it, WebRTC stuff. We're seeing the zombie plus text now. Still no sounds though. Yeah, I don't know. There's like something just broken with it or something. I don't know. Lockham, thanks so much for the follow. You don't want to pronounce my first name, not to talk about the last one. What do you mean? Okay, so this could be an option. This would be the path of least resistance, right? Where we just create a hash map that goes in here, where we could just say, you know, options, and then we could say, you know, I don't know, stun server, right? So we could do that. That would be the easiest way of doing this. But it would be nice if we could have a full JSON body that is unique per type. But I don't know whether we can read partway into this. I mean, maybe this is just the way, right? I'd love feedback here. Is this a terrible looking API? I kind of don't like it, but because I feel like all of the parameters should be here. This would make it easier, I think, because inside the filter, we should be able to do something where we look at the parameter and maybe be able to pass it on here. I don't know yet. No, so the terminal prompt is starship.rs, which is I actually really love it as a terminal prompt. Okay, so I don't know. I really want to solve this problem, but I also really want to work on the WebRTC stuff. Cargo watch minus X Clippy. Okay. All right, because it's standard collections hash map, I think. Right? Yeah. Did I just crash Vim? This has to have something to do with Rust Analyzer or something, because it seems like every time I try to separate or I try to organize these in this way, that's when that happens. Kill all of them. Maybe I can get Tej to help me look at that sometime. Was it in input or was it in filters? It was here. All right, so we need use standard collections hash map. Okay. My recommendations for learning computer science on Coursera do how to design programs. After that, do from Nan to Tetris is really cool. I actually thought about doing that before I took on this project. I thought about doing that as like a study group where we get a bunch of people to all sign up for the course at one time, and then like one day a week, I'll just get on stream, and then we like all try to work on solving and building whatever the next thing is. Okay, so this is the easiest way to solve this. I just don't like it. I just don't like it. Because I almost feel like each of the individual types, right? So let's just create a new one here. So tab new, input or source input WebRTC. We're just going to create a new input. I'm going to come over here. Let's grab the fake one to begin with. This would be the easiest thing to probably use for a template. Okay. Wait, no. Input WebRTC. Source input WebRTC. Okay, there we go. Oh, because it's not in Git. Git add source input WebRTC. Okay. It's an ugly API. Okay, yeah. So that's invention and innovation. And the problem I suffer is I don't like this either. I mean, from like a JSON API standpoint, it's not going to be that bad, but internally I hate the representation of this all being generic strings, right? Like, what if the property needs to be, you know... So maybe we should try to investigate this a little more. The problem is just how do we figure out... We almost have to parse the body twice, right? Always Truthy, thanks for the follow. Which we really don't want to do that either, right? Just from a performance standpoint, we would prefer not to parse the body twice, but I don't know what other options we have here. Everyone knows that Eric is a Discord pro and needs to teach Began to patch the problems. What problems does Began have on Discord? And I don't know whether I would say I'm a Discord pro either. Oh, you can still at roles in Began server? Okay, so... Okay, so... So we know that this just uses Serday, right? So we could potentially try to get the bytes back, right? And then let's look up Serday. Serday JSON. Okay, so there we go. So this is from string. We want to go the other way. We want to take... Here we go. So from string. Okay, so we may be able to do this. Okay, so if we did warp body bytes, we in theory would have back a slice of bytes or an array of bytes or whatever this is that this returns. It looks like it's an actual type here. So I guess we could use Saturday to parse it twice, right? All right, let's play with it. If we can get this to work, it would create for a much cleaner interface. All right, hold on. Git reset source input. Because now we're gonna we're kind of like working on two things at one time. Okay, so let's see what we can do here. From JSON body. So here, now we should have bytes back, and okay, so that goes on top. Okay, so we should be able to say and here, and then our bytes would go to another method. Can we just do a closure here? I mean, let's try it. Okay. And then I'm just going to return back like maybe like a struct literal or something. No, I guess let's just see if we can inject ourselves here. So this should be Saturday JSON, right? What was the example they used? From stir. Okay. From. Oh, is there something else? From slice. And what is B? All right, let's look to see what type B is. Hey Rockstar, what's going on? You're going to sleep. What time zone are you in? I thought you were West Coast. Thanks, man. PST, it's 3 p.m. Did you stay up all night? Oh, there's no judgment. I'm just curious. Like, is that your set sleep schedule, or did you like stay up all night and you just haven't gone to bed yet? Okay, so so this and is not gonna work. So does map work? Okay, what are you talking about? Okay, because this is expecting that we're going to return back bytes, which is not what we're doing. All right, I messed up this somehow. This returns back a future, right? Returns a filter that matches any request and extracts a future of a concatenated body. The contents of the body will be flattened into a single contiguous bytes, which may require memory copies. If you don't require contiguous buffer, use aggregate can give better performance. Okay. No, because I think we do need the contiguous body, don't we? Okay, so this does not work the way I thought it would. I mean, I do know that the Saturday part of it will be okay. We just need to figure out how to work with this. So let's go look up this filters thing. No, see, that's what they're doing here. All right, there's got to be something going on with like Rust Analyzer. That's going to be my guess. Kill all Rust analyzer. Come back to me, Vim. This is what you get for living on the bleeding edge. All right. Off to bed. All right, man. Catch you later. Okay. So, from JSON. Okay. Oops. Okay. What am I missing? All right, that closes that. That closes that. Okay, so we're missing that. Okay. Use of undeclared module bytes. All right, so we just need whatever import this is. All right, we're missing. Okay, so we're missing this in our cargo file. That's it. All right. Bytes equals, I don't know what version. This is here. All right, so we'll just say 0.5. Okay. Expect to get a unit struct, found struct HTTP input request. Hope what works. Like this trying to modify it, or like the WebRTC stuff that we're ultimately trying to do? Okay, so why is it expecting a unit struct? So just do the way this is returning. Like, what if I return back a Saturday JSON? Oh, because maps not returning anything, right? Maps are returning back a unit struct, right? So really, we want Saturday JSON. From, I'm guessing it's going to be a slice, right? Bytes dot as okay, so I think it is just a VEC-U8, right? All right, let's just pass this. Okay, so if we return back the result of this, and we're gonna just say unwrap here. Totally not safe to do, but right now we're just trying to figure out this API. Oh, the JSON stuff. Yeah, because yeah, I want a cleaner API than that. Okay, so it is implementing deref for us. So if we just do this, we should get back an array of bytes. No. What are you talking about? That is, oh, duh. Here. You are, there we go. What were you working on today over in your channel? Okay, so we are compiling now. So this seems to be doing what we want. Let's try it. Cargo, run. I mean, this is not, it's not ideal, right? But so we should be able to take this, convert it into like a generic function that we'll just call in all of the filters. And then we can have individual ones, I guess, on the inputs, right? So then we could do like a from JSON on each of the inputs and then create them that way. And I mean, if this works, then we would be able to have like individual configs for each of our types. And that would be ideal. Okay, so let's ignore this. Oh, we're gonna have to recompile this because I still have this on here. Wait, where's my mouse? There we go. I still have this on there, right? So from us sort of like talking about like what our potential options are. Thanks for the sub. What were you working on, Dembski? What were you working on in your channel today? Were you still working on the same compiler bug? You know what's interesting about Twitch subs is all kind of like the circular reference of all of it. Like, do you know where all of my Twitch sub money goes? Like people subbing to my channel, it just goes to me subbing to other people's channel. So it just ends up being like this circular thing where Twitch just takes half of our money, you know? Free money for Twitch. Yeah, that's basically the way it works, right? Yeah, Twitch is smart, right? Okay, so let's add our mixer. Add our input. Oh, okay, so that blew up. What is this? Oh, trailing comma. Okay, so let's restart this because it's just broken JSON. I mean, but at least that says that it was trying to parse the JSON. And it was created. It was created. Okay, awesome. Awesome. All right. So, wise old bird, it worked. So that means that we should be able to come over here. We are going to open our filters here. We're going to need a helper method here, kind of like this with mixers, right? It's going to look, I guess, something. Now, let's do this. We're going to copy this function here. And we're going to say, no. I want to leave it in here. We're going to take it from here and we're going to create a helper method somewhere in here. Okay, so here we've got our from JSON body. That's fine. And instead of self here, we're going to return back a Are we even create input as, okay, mixer input. So we are going to return back a mixer input here. Okay. So now what we need to do is create some sort of smaller type. Speaking of Twitch things, what camera do you run? So this is a Sony 6000 series camera. Like, there's a bunch of them. Sony, what's this one? This one's a 6500, I think. I mean, it wasn't, yeah. So there's like a whole series, 6000, 6400, 6500. Yeah, it was a nice mirrorless that I had. I like that, it has, so nobody's going to show it. So here, this screen flips up, and so you can see it from the front. And nobody has it previewed. Of course not. But yeah, so you can kind of see how it detaches, so it flips up. But yeah, I had this nice mirrorless camera, so I just hooked it up. And you mentioned NDI. No, so NDI is just something I've played with for other things. So this is connected directly to my computer. So it used to use something called a cam link, which is just this like USB device, and there's cheaper versions of them, where it's just a little dongle that you plug in the HDMI output from the camera, and it plugs in, and your computer sees it as a webcam. So I do have one of those around, but now I actually have a hardware capture card in here. I was trying to solve another problem that I had, and so I ended up buying a hardware capture card, and that's what's in here now. So I have like 2 HDMI inputs, and it's just straight to the PCI bus. But that cam link was fine. I had an issue because I wanted to have 2 cameras when I was doing some embedded stuff. I wanted to have like my main camera and one that was like on the embedded device while I was working on it. And I was having all of these issues with having a 2 camera setup and it not working correctly. So I was thinking that it was like contention on the USB bus from having multiple USB cameras. And so I ended up buying a hardware, capture card for it, and that actually didn't solve my problem. So I ended up having a hardware capture card. So I'm using it now. It's awesome. But yeah, it turned out my problem was Windows. Apparently Windows didn't like multiple cameras for some reason. And I think that the reason for it is it works for most people, right? So anybody else who's using Windows, you probably won't have the problem. The common theme that I found from people I knew who were doing multiple camera setups on Windows and them working in mine is that I'm running multiple CPUs. So I'm guessing that maybe the cameras end up on separate CPUs and there being some weird thing. I've noticed my cam link is unreliable when plugged into my Thunderbolt dock, but is okay when plugged directly into a laptop USB port. Interesting. I mean, I can see some of the latency and stuff like that, but yeah, Okay, so here, I guess we need to figure out what we do here. Can we just do this? It's a known issue when you use the same model camera model and the manufacturer driver a Logitech when they get to UVC, all it's fixed. No, actually for me that didn't matter. It didn't end up mattering. So I would have like a Canon camera plugged in using a cam link and then a Logitech webcam and stuff like that. Hey Matt, how's it going? Yeah, I'm doing some Rust, building an RTMP switcher. I don't know, have you been here while I've been working on this project the last month or so? Okay, so it's expecting a standard result. What does this return? but does return back a result. So why does this think that we found an input? Oh, because this is a standard result. Right. So we need to figure out how we're going to return back the error case here. You missed when we switched to implementing go to Rust and then ran it over everything. Rust Evangelism Strike Force. Yeah, it's actually a really fun project. It's going to be really interesting as it comes along further. I've seen that when the USB hub doesn't have enough USB full speed chips, you basically need one to step down every port, or you get all ports step down to lower speeds. I had a lot of issues with this and running digital whiteboards. Yeah, and sometimes like when you're running like your audio interface and all those things over USB, that's why like even though the capture card didn't solve my initial issue, like I'm back on Linux. That was just a temporary thing to try out Windows for a bit. I kept it anyway, just because, hey, why add contention to the USB bus? Okay, so this is returning back a result. However, this filter says that we can return back a warp rejection error. I need to look at that. HTTP mod. Right, because we need to do this like reject custom thing, right? I think. I'm trying to remember how all of this stuff works. Have you used warp before, Matt? Okay, so if we do a match here on the result of this, if it's okay, this would return back our, what do we want to call a request? We'll return that. If it's error, then this is where we need to return back this reject custom, right? Reject custom error. And I don't think I'm importing this, right? So where's reject? All right, let's go find warp. Wait. Okay. Is that right? What am I missing here? Like maybe the display port bandwidth spikes and delays the USB ports. Oh, that's true. Yeah. Yeah. If you got too much stuff on there, yeah. Wait, why? Matt, thanks so much for the sub. But yeah, so today's mission, it was to actually was to get WebRTC working. And so we played with some demos, and now we're in like the we must refactor our code so that we can actually implement this phase. Okay, so this is under warp HTTP. This is fine. I believe that is at warp filter, right? No. Filter. Yep. Okay, so that's at the top level. It is reject. And it is reject. Reject, right? Okay, so what on earth are you complaining about? What is this? Okay, yeah, I know. Oh, okay, so it's just the LSP stuff, right? Wait, what? Okay. And that's not used anymore. We'll get rid of that. Okay. Gotta go grab something to eat. Catch you later if you're still streaming. Yeah, I'll probably be streaming for a couple more hours. I'd really like to see some of this WebRTC stuff implemented. I wasn't thinking about the having to refactor for config, but I would really like to tonight get either the switcher pushing out to WebRTC or pulling in video from a WebRTC. Okay, so expected struct warp rejection found enum input. Okay, so because reject is not implemented for here. All right, I don't exactly know what we need to do to get that implemented. I don't know enough about warp to properly be able to do this. Implement reject for error. Okay, so here's this error thing that comes in. And I don't, so we can't implement reject on here. So we need something that it is implemented on. But I thought we had, didn't we just have this working? Okay, I'm super confused because I swear that we had this working. Oh, because unwrap, right? Oh, wait. No, because we changed all of this. That's right. This is our helper method. This isn't the one that we had working, right? This one's the one that we had working. However, the only difference is the enum. Right. Okay, so here's our issue. Because we're this whole time I'm like trying to solve errors that are happening, and I'm trying to do it here instead of the one that it's actually happening in. Okay. And we don't really need to spit out what those bytes are. Okay. So we can't get reject to work here. So what do we return back? Okay, so expected struct warp rejection found enum input. Well, enum input is not our issue, right? Because we could in theory comment out this, right? And just say, let's just we're going to be silly here. So on the error case, we're just going to say mixer input create URI, right? Test. Oh, it's going to want to config too. Input config. Okay. Do you have any recommendations for getting started with Tokyo Futures? I've been wanting to do a high-speed networking project with Rust, but have been intimidated by what feels like a moving target with async await idioms. Yeah, I feel the same pain a little bit too right now. I'm still learning all the Tokyo Futures stuff myself. It's all kind of, this is where Rust starts getting confusing, right? So, you know, everybody talks about like the learning curve of Rust. The basic syntax was pretty straightforward. It's when you start getting into all like the Tokyo stuff and futures and all of like this crap, which is really just like macros that are like generating code for you, and it's just all right. Standard result found enum input. I'm not really sure why this error is saying what it is. All right, we're missing audio name, record, and one other field. All right, so we need to do a audio config default, right? And we're going to do the same for video config default, record false. What other field are you going to yell at me for? Encoder, I think, right? Expected struct input config found. Oh, right, because we don't actually take this anymore. So it would be name test dot toString. Okay. And I think it's going to be encoder too that it's missing. Wait, what? All right, hold on. Now I'm forgetting stuff. Input mod create URI. Okay, it took config first and then a name. Okay. Ownership macros futures are what give me trouble. Yeah, and lifetimes. Lifetimes, definitely. Like whenever I get a lifetime error, I just refactor the code until I don't have a lifetime error. I still don't fully understand what exactly I'm doing to fix stuff. Wait, so why is... Oh, because it's not name, right? The second parameter is the URL, right? So we still do need a name here. Test toString, right? Okay. Okay, so expected enum standard result found input. Is that just because we need to do return OK on it? Okay, so this is still confusing me. Because both of these now return back result, right? Oh, wait a second. No, wait a second. Oh, crap. This whole time I've been trying to figure this thing out. This from slice thing is trying to interpret it from here, right? Because that's how we're telling it what type we want to return. So that's... And that's not really what we're doing here, right? So... All right. Okay. So here's what we're gonna do. We just need to rethink all of this. Okay. Okay, so this is our starting point, right? We really don't need that other one to look like that, but okay, so okay, so here's our bytes that come in. So really what we need to do is, how is Ceraday doing this? How's it determining what type we need? It's going based on this. Okay. Okay. Here's what we got going on. Okay, so what we need to do is we're just going to say let I equal... Nano Alex, thanks so much for the follow. Okay, so we need this to be an input or a mixer input, right? This is ultimately what we need. And this would be... Well, no, okay, so the first thing we need is our type here, right? So this would be the create request, right? So, and we're gonna have to change these types up a little bit, but we need a create request from our Ceraday JSON from slice rather. Okay. And then we're going to pass in our bytes. Okay. So now this gets us our request, right? I don't know what you're complaining about yet. Okay, so let's go with this. So this would get us our request, right? And then from here, what we really want to do is we want to look at its type, right? What do we call it? Input type? Input type. Okay. So here we would match on our request.input type. And we're kind of already doing this somewhere else. Is it in here? Oops. Input type. Okay. So we already have like a switch somewhere in here for this. Yeah. So this is where we're basically deciding what type to do. And this is already inside our add. So we're going to just end up doing the same thing anyway. Except so we're going to do the same thing, except we're basically going to shift it up one level. So what'll ultimately come into this method is an input, not a create request, but an input. So we'll fix all of that, but well, I guess if we come up here, we have all of our arms that we need, right? Here, right? Basically have all of these. Right. All right, so these are all the individual types of inputs that we have that we could theoretically have to create, right? So I'm just going to use them all as one type for now, just because we want to prove out this logic. So fake. And test. Okay. So that's not going to work. And we deleted our all right. Okay. All right, how are we doing this? How are we doing this? I guess what we'd ultimately do is this, right? Create from JSON, right? And then we would pass it our bytes, right? Maybe that's what we should do to begin with. Okay, yeah. I mean, it starts putting logic in a lot of random places for JSON. So I'm slightly concerned about that, but I don't mind having a dependency on it in our types for serialization anyway. But it might make sense inside this enum to just have like a from JSON, and then we pass it in the bytes. But we could do it here too. What we just end up having is a series of types though. So we have this create request here, but then we would end up having some additional types here. So we would have like a pub struct create URI request, something like this. And this would have the individual things on it. I wish we could compose here, right? Because it would look something like this same thing, right? And then we could have the individual properties, right? So we could have like, you know, stun server. It's a string. Something like this, right? Okay, so I mean, let's use this as a starting point, right? So we're basically going to just say we're going to assume it's a URI. So then what we really want to do here is return back let. We're just going to override it. So we're going to match on the input type here. Now I guess we would want the results of this. This is not really what we want here. So we're just going to say no, we still need to do it. All right, so I need to think this out. This is one of those things, like, I think when you start moving too fast and you start thinking about too many things, you start confusing yourself. So usually what I like to do is just like back up for a second, and then I'll comment kind of what the the full like flow of what I'm thinking, and then I'll try and hydrate that. Okay, so the first thing we need to do, Max, how's it going? So the first thing we really want to do is we want to parse the body for the first time so that we can see what is stored inside input type. After that, we need to parse a, I guess we need to unmarshal the same JSON a second time, but with the proper input type. So I don't yet know what this should look like. Do we have a separate request type? Or do we implement serialization on the types themselves? We're going to have to populate them anyway, so that's not going to work. Electronics Wizard, thanks so much for the follow. So the overall project itself is an RTMP switcher. Really, we probably shouldn't call it that anymore because it's becoming such much more than that. It's basically like a virtual video switcher. So we have this component here that we're building. We can have a bunch of streamers pushing various stream types, so RTMP, things like that, or we can have videos. And what we want to do is layer them into each other so that we can create one constant feed out to one or more places. We can do picture-in-picture, we can just switch between them, we can use a scheduler to control this all over HTTP. So our mission for today that we were working on is trying to implement WebRTC. So if you've ever used in-browser conferencing, you're doing WebRTC. And so we want WebRTC for two reasons. We want it for output so that we can preview these inputs in some sort of like production browser studio here, and the output. We also would like it as an input so that somebody could just go to a browser and get injected into the video feed. So all of that has brought, to our attention sort of that right now we just assume a generic input type from JSON coming in through the API. But now we need to have different JSON based on which input type that you're using. So I'm currently looking at how to refactor, our incoming input create request into something that's more generic, where we can use an input coming in, we can look at this input type and then realize, oh, okay, we need to actually unmarshal the JSON into a whole separate type that is very specific, right? So the create URI request, or I guess here it would be a create WebRTC request. Well, that really has, additional fields, right? So we have a stun server, we have a, we have a turn server, and then we have a WebSocket server. Okay. So, right, so each one of these types may have different configuration to them. And so we need to figure out like a generic way of doing this. And so that's sort of what I'm exploring right now, because I'm new to Rust, I'm new to this Warp framework. So we've sort of figured out that we can grab the bytes of the body. And so we're serializing it into here, and now we're trying to figure out what to do. Okay, so we have this request type. We're going to look to see what it is. So from here, I guess we would end up having a, let's just say it's a, okay, so we can't say what type this is going to be. We can't say what type that's going to be. So the end result of this has to be something else, right? Because match needs to return back the same type. So we would end up having something like this. This would be the input, right? I guess technically it doesn't matter. We could just return this back. Okay. I don't know how this is gonna... What am I missing here? Well, first that needs a semicolon. Okay, so here, I guess we would end up saying let request equal so we've parsed this. So what we need to do is inside of here, at this point, we know what type it's going to be. Right now, I'm just saying it's going to be all of them are going to be the same type. So this would really be, we need the type, which would be a create WebRTC request. And that's going to equal Saturday JSON from slice and bytes. Okay. And then once we have that, that's when we would end up doing the same logic, right? Input type, input type. Right. I'm mixing up way too much stuff. Okay, so basically this switch right here, right? So this is where we need to basically be using all of the same stuff. I'm just going to paste this here. Right, so we already kind of know all of the information about it, right? So here's the input config, right? Except the config is going to be different. We need a helper method for this. Okay, so this would be the request, right? So at this point, this would be the config that comes in. Config.video, right? Config.audio, config.record, okay. Yeah, there's no need to be a request type for the first run. This only needs to have the type property and then parse again. Right. Yeah, so wise old bird, I'm just like sort of refactoring to test the theories, and then I'm going to refactor the types. But yeah, I'm totally with you. We're just going to have a type that just has a type property on it, and that's what it'll serialize into. Right now, I'm just sort of like trying to get like a working little prototype of the code, and then we'll make it something that's actually what it's supposed to be. Okay, so, you know, there's a part of me that wonders whether I should separate the HTTP types from the legitimate ones, but then, you know, like here, what do I need all of this for, right? I mean, because the reality of this is, right, I could just have a input WebRT. It's not in there. Source input WebRTC, right? So really, oops. Let's just replace fake with WebRTC. Okay. So this is our starting point. So I could just have a pub struct config here, right? And then we could put all the serialization here, and really that's probably what we want. Because what else would you be submitting, right? So it's almost like, shouldn't all of this just be in here, right? I mean, I feel like that's it, unless we feel like there's something on the HTTP side that we would need to look at or do something with, or additional options that the input doesn't necessarily need, right? And because right now record is actually implemented inside the input. So I almost feel like that might be the better place for it. Okay, so this is all warp errors because of this not working correctly. I'm not sure why. What is all this yelling at? All right, let me first make sure. Okay, so this should all be fine. Okay, so from here, we now have a config. So then we should be able to come in here and just say, yeah, mixer input create fake, right? And then we'll just pass it this config, right? So this should then return back a mixer input from this match, which should then return it back from our function. But that is not... Wait, what is all this? We have another error somewhere else. I think, what was it, reject that's in here that we don't need? Yeah. Okay, what did I mess up now? Did I mess that up? See here? So we are making an RTMP switcher. Well, it's a virtual video switcher, basically. We want to run this thing in the cloud and have a bunch of different streamers pushing to different RTMP endpoints and be able to like layer their videos in picture or switch between them, fall back to videos or play videos in between, and keep like a linear video feed. So like basically think like a TV station just running all of the time. So for like a conference, we could have these different speakers connected to different RTMP endpoints. We can preview them and we can push them out. You know, 2 o'clock, the scheduler says put streamer 2 live, things like that. And right now we're doing some refactoring so that we can start working on using WebRTC as another type of input, as well as being able to use it as an output for preview and things like that. Wait, what am I missing here? Am I messing up like a basic variable declaration thing? I'm gonna laugh. Rust variable declaration. Yeah, that's right. What are you complaining about? Expected one of. Let's look at the line above it. That's right. I guess I'm not understanding what this is yelling about. Let's look at our Saturday example here. Right, so, oops. So we're doing the same thing, right? So what exactly is it yelling about? Okay. This is gonna drive me nuts now. This is valid. This is valid Rust. What are you complaining about? Did you derive? I did not derive. I did not derive. Godly anime. Or no, key value. Thank you. Oh, wait. No, that didn't fix it. Okay, so we're still complaining. Cargo Tommel. Cargo Tommel. So, I mean, we've got derive here. Do I need it inside of Saturday JSON? But I mean, I could have done this from any type, right? So, I mean, in theory, if I also did create request here, right? Let's just check to see whether the errors go away. Because we know we're already doing that here, right? Okay, so I'm missing something here, right? Because didn't we already... We did it here, right? Yeah, because self here, right, is a create request, right? So this same Saturday JSON is still working here. So why would it not work here? Am I missing a trait import? I mean, both those are imported. I mean, we shouldn't need JSON result. So like, what is the difference here? All right, I'm gonna comment out. All right, we're gonna comment that all out. This should all compile. Okay, from JSON. All right, so let's try this. So we're in here, and this is returning that back. So in theory, we should get the same thing if I said let R equal, right? Oh, then we should just return back R, right? Closure in map. The closure's there. Hold on. Mismatch delimiter. Oh, because I didn't do this. All right. Right? Oh, right. We're just experimenting here. Like, what exactly is our issue? Okay. So here's this. And this is the same thing, right? It's a create request. So if we did create request here, it's effectively the same thing, but this is what's blowing up. So this compiles, right? So this compiles. Okay, so, but we're doing the same thing, right? Oh, wait a second. You're right. You're right. I think somehow our, closure came up missing. Because I don't see it anymore. Okay. It's such a weird error though, too, right? Hey, Pandora. I appreciate that. Although I don't feel very successful today. Okay. Expected structure string found. Wait, what? Do I really have to do this on each of those? Or can I just do this? Okay. I was like, that would not be fun. Expected struct standard string found. Why can't I do as... Because this is a string, but I want to convert it to as bytes? No. As st. There we go. Yeah, this is what I want. Not found in the scope. Oh, request. 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 Okay. Oh, we're getting closer. The question mark probably doesn't work here. Yeah. So it's not implemented. So I still don't know how to return errors from here. We're gonna have to figure that out. So for now, we're gonna unwrap. And we're gonna do the same thing here. We still need to figure out how we can return back an error here, because that reject didn't work the way we expected it to. Expected standard result found enum input. So, okay. Ah, I thought we were going to have it. Okay. I'm not sure. Expected enum standard result found input. This would be a result, and the input is inside of it. So what am I missing? I mean, we could do this, but this is an expression, so it should be returning back the result of it. So yeah, it's still the same error. So it's nothing to do with it like returning early somewhere and doing that. All right, so it's something warp related. And I find that like in the time that I've been trying to learn Rust, most of my headaches have come from warp and trying to understand what's going on, because it uses a lot of like crazy language stuff that I don't fully understand. So this is a mixer input that it returns, right? Wait a second, it returns back a result by itself. Oh, crap. It's reversed. Create fake returns back a result. Okay, maybe not. Pattern and underscore not covered. Sir, we're not missing? Or that we're missing? Okay. All right. I'm gonna use the restroom real quick, and then I guess we'll start trying to refactor some of the. Actually, I think the first thing we need to do. Let's to do this. To do. How do we handle our error cases? No unwraps. Okay. Actually, you know what? I'm gonna come up here and do it. Okay. So, additionally, we need to refactor first request type to just be input type, right? I'd also like to see, like, is there a way that I can tell Saturday what the name of this field is, right? So that I can just say type, but we'll look at that as we go. I guess that's a starting point. Okay, hold on, be right back. Going to bed? All right, wise old bird. Hopefully I get this all refactored, and then I can move on to WebRTC stuff again. And then once we get that figured out, I'm going to implement a browser source too. Okay, so first thing we want to do is we got to figure out error cases. So I really want to... How do we get this to return an error? Can I... Where's the... Because we already had the reject thing, right? No, it was HTTP mod, right? And then it's custom, right? So this is where we still want to implement... You go away for now. Go away. Okay. So we still wanna include reject here. Because I think that's what we're gonna end up needing. Reject error custom. Or no. So reject custom. Oh, right. Because this is just like, we just have this HTTP. So we should be able to just do custom and then super error. Is that gonna work? Ah. Okay, so 283. So here. So is this because we need to do like this? Is that what I'm missing? I'm not fully sure what this is returning. And if that's the case, then we would want to return an OK here, right? Because then we'd at least get back a result. What am I missing here? Yeah, that's what I'm trying to figure out. Key value here is it returns back that's what the must have statically known side thing usually means. Yeah. So I'm just trying to figure out how to get this to return back. So it's okay on the happy path, but what I need to figure out is, I guess, I mean, in theory, can I just do a return, reject, custom, and give it super? Oh, wait a second. So here's the issue, right? Because all of this is inside of a closure, right? That's our issue. Okay, I think. So I think what I'm getting thrown off by here is we're getting this error up here and everything, but I think the issue is that... Where are you? Okay, so this is a closure, right? So all of the returns that we're doing in here are just what's being returned back from map, right? So we need to end up making this return the same thing. And I think that, can't we do like a, like I think we can actually get that to return back a specific type, right? Okay, so apparently we can't use that there. What does custom error return back? I want to know. Reject custom. So it returns back a rejection. So shouldn't we be able to just do like, okay, and error, reject, custom, super, error. Laundry? Alright. Map will take something on the success or some cases. I'm trying to figure out how to get just a expected value found enum. But isn't that what we're doing here? Oh, error is of type that. Duh. Okay, so reject for error, but error. Oh, no. Okay, so we have an error type here. Duh. Okay. I'm dumb. I'm just gonna say unknown for a second. Does that compile? No. Expected standard result found. So, but what if I do this? So this seems like it's complaining more about what's being returned but from our match, right? That it's saying expected that because that's what we're returning from our match. And I guess I would think it'd be the opposite, right? Where it's telling me, hey, like we're actually expecting this type, but we're getting a rejection instead. I guess I'm confused what this case is saying. Yeah, I really don't want to implement this without handling the error cases. So I just have to figure out how to get this to work. Like, can I do... Okay. So would that allow me to do... Oops. Maybe you don't handle the air in the closure, but outside in the closure. Well, that's sort of what I'm trying to figure out, right? Method not found in, wait, what? 284? Yeah, so that's sort of what I'm thinking, right? Is so this should be a result, right? Where's the other unwrap? So this should return back, you know, some sort of result from here, maybe? So this would end up being a result. Wait, the match would end up being a result, right? Which I should be able to call unwrap on, right? No? Wait, why are we getting back a tuple? What am I missing here? This should return back something. Why are you there? All right. So what is this returning? I mean, so in theory, this should be returning back a result, right? I mean, you would think. All right, so I just need to figure out how to get the error back from the closure, right? So maybe if I did this, what if, where's my closure? What if my closure returned back a result super, nope, input, nope, mixer input, or a super error, right? Okay. So what's this complaining about now? All right, because this is that. So in theory now, I'm just gonna come here. Wait, huh? Oh, crap. I hate when I do that. Okay. That's why. Nope. want to know what this all returns. Okay, so this returns back. Right, okay. So why does this not work? Okay, so here's the match. But the match should be okay, right? It's really what's being returned from the closure that we're interested in. So why does that not work? So we need to like basically wrap this or unwrap this. So the closure is returning back a result. Oh. All right, so I think I know what's going on here. And this is like sort of like the confusion sometimes with functional programming. That is this filter is being called and its result is being handed back, which is being handed back, which is right. So how are we going to do this? How are we going to do this? Because this closure just returns back something from map, and map goes into this filter chain. So I don't really know what that's going to be yet. So can we do something on the result of this? I mean, because we don't really know what it's going to be yet, right? So that's going to work, but we're still not handling the error cases. And I don't know exactly how we're going to do this yet. Oh, well, you're going to complain because... Okay, so I don't know. I don't know whether like use this for right now and wait till I can get help from somebody who knows Warp a little better. Because, I mean, this will work, but it's not going to handle our error cases very well at all. And I'm just not entirely sure how to get this to work. I guess I thought if I return back a rejection here, that it would be okay. Right? I mean, because in theory, we should be able to do something like map error, right? And then just return back like a super error unknown, right? And then do this, right? And then do the same thing here. Maybe not. Cannot use operator in a closure that returns input. Okay, so I guess we would need to return this back, right? It would still need to be this result. Mixer input or super error, right? So then the question mark thing should work here, right? Expectation to result, found enum input, Right, that's easy enough to fix because we would just say okay, and we'll wrap that. Let's worry about one at a time. Expected closure that takes one argument, right? I don't really care what the error is at the moment. I just want to get a working error case. Okay, so this is the same thing. And that's because this closure returns back a result. I mean, but can I do anything here? I just wonder, like, can I do like a... Yeah, here we go. Map. So this would be R, right? Wouldn't I be able to just do match R? And then if it was okay, right? Then this would be our input. Return back input. If it's not, if it's an error case E, then I should be able to just do reject custom error. Will that work? Whoa, no. Something went wrong. Because the idea here is that whatever is returned from this, we're chaining them, right? Wait, what am I missing? There's a dot map on that. Yeah. Okay, so what's the compiler complaining about? Alright, missing closing delimiter. Wait. Okay. Expected signature of... Oh, okay, so I need to actually give it its type here. This is result. Mixer input. Super error, right? Expected enum input found struct warp rejection. Crap. So why does that not work? So close. Yeah, so how do I get the error case here? That's what I don't understand. So I figured out how to map all of this stuff back out so I can do something. But I want to know how I get this warp rejection. How do I get the warp rejection? That's what I want to know. See, here we're returning back a result. And a warp rejection looks like it's just an error case. So why does that matter? Okay. I still don't fully understand this. Why can I not do this? Well, this is crap. So this is still the closure. Ah, crap. Is that what's returned from up here? Can I do this? Wait. Because this is actually returning back that from the closure. And what we really need is for well, this is sort of a pain. Oh, I really wanted to do WebRTC stuff. Oh, we know all this, right? Wait, didn't we just have this all working? All right. What type is this? All right, because we're returning back. Might need to comment this out and come back to it. It's getting kind of frustrating. I feel like we're so close too. Like, I mean, I like we could probably change this, right, to result mixer input super error, right? And it would probably compile. But like that's not what we want, right? We want to be able to return back this error case. Because I think what we would end up with here is we'd have to unwrap it twice, right? I think. I mean, it would work, I guess. I mean, let's try it. Well, we need to do some other refactoring first. Okay, so let's just say WebRTC. No. Input WebRTC. Okay. So here's this. We'll just use the config for now, I guess. Okay. And for our input, we need to introduce our new type. Oh, crap. Source. Okay, hold on. Input, mod. All right, so we need to introduce our new type here. So this is going to be our WebRTC input, WebRTC, okay. And then we need to implement all these. WebRTC. Okay. Beep boop beep. Thanks so much for the follow. Transistor92, thanks for the follow. All right, I'm gonna move this up. Okay, WebRTC. WebRTC. Ah. Okay. I wonder if there's like better libraries for like the HTTP stuff. That's the thing that I seem to have the biggest struggle with. Hey, C-Bro, yeah, still going. We got some basic demo stuff working from a GStreamer example I found, actually written in Rust, that was sending bidirectional WebRTC, and then we moved over into trying to get it into our into the streamer itself, and then that brought up a whole host of issues with like configurations that are only needed for specific input types and things like that, which in turn led us into a bunch of banging our heads against the desk trying to debug issues with warp that I still have not figured out. Okay. Oh. So this is going to be interesting. So warp is the HTTP library that I'm using. Although I just realized another problem, that we now have like this config helper here, which is not going to do us any freaking good. Crap. I wonder if anybody's calling this. Wait, where is that? Source input mod. Source input mod. Ah. Yeah, it's more like how to refactor all of this stuff, because right now all of our inputs have one config type. So the introduction of WebRTC now creates like, well, we need all these additional configuration parameters and things like that only for specific inputs. And, you know, how do we allow for that in the JSON? You know, like one obvious solution is just using a string hash map, but I was trying to avoid that. Although at this point, the amount of time I've spent on this, I kind of feel like maybe I should have just went that direction. But I just feel like long term, that's not the right approach. So I'm just trying to figure out how to. So undeclared. That is it. So what am I missing? Oh. Ah. WebRTC. Okay. I spent a while upgrading Windows to get the WSL2 with GPU support, but then realized that Docker Desktop doesn't support it yet. Oh, that sucks. Potatoes, how's it going? Conflicting implementation of input config. What? What? Where? Where? Line 7. How is that conflicting? Isn't that a inside of the WebRTC module? Oh, because we've got like use super config. I'm fighting Rust so hard today, potatoes. Alright, input location. Oh, wait. Did I remove that from the config? Alright, I'm going to put this back for now. Alright, I broke so much stuff. What did I do? This is going to be a crazy refactor. Alright, so this is expecting to struct input config, found struct WebRTC config. I know. Because right now we're kind of trying to separate things out a little bit so that each input type can have its own config. So like this is a generic one right now, but you know, like WebRTC really needs its own config, right? It has a bunch of properties. So that's sort of the problem that I'm trying to solve now, is I want to be able to have different JSON for each input type. But like this is getting like so crazy out of hand that I'm half tempted to just introduce a string hash map of options. Right. I mean, I'd really prefer not to, but so that's sort of what I'm struggling through right now is trying to come up with options here for all of this stuff. So now I need to figure out, I think I'm going to have to implement like a config trait now. Because I need to figure out everywhere that that's being called now, right? Like AG, is anywhere actually calling that? Wait a second. I may luck out here. Okay, let's I'm gonna look for where's the config function. All right. Okay, there is one inside the mixer. Crap. What is that being used for? Mixer mod. 254. What do we got going on? What's in here? So that's just to ask about the volume. Right? Is that all we're using it for? I mean, because if that's the case, I can just add a method to ask for its volume. No. It's also being used for the Z order. Okay, so I could just convert this to Z order and volume and create methods for those, and then I don't have a reason to ask for the config. Have you used config the library? I have not. Is that something I should look at? Rust config lib. Okay, so this looks like from files and things like that. Layered configuration system, set default, set explicit values, read from JSON, TOML, YAML. Okay, so this we could just potentially parse then, right? Rather than using Serday. So the question just becomes, right, like how do I figure out the individual type? I guess I would still need to do the same thing I've been doing, right? Parse it twice. What is value? So this like gets into a situation where like if I need it as a certain type, it's gonna end up panicking. So I have to figure out how to trap all those panics then, right? All right, so we've got a couple of issues here. One is I still have to worry about this error handling here. And so this is what I ended up with, Patatas. Basically, I'm getting the body as bytes, and then I'm using Serday to just parse out to figure out what the input type is. And then I'm using Serday again to actually parse out the legitimate type, which is going to end up being a config, and then I'll create the input type. And so this works, but I'm in a situation where error handling doesn't work, right? So I'm having to return back like this result here. It's a solution. But now I also have like this whole shared config thing. So I think what I'm going to end up having to do here is change this, right? Volume, right? Wait. So if I did something like input volume, right? And then input Z order, right? Right, because that would still return back an option. Okay, so then we would need the function Silent King, thanks for the follow. The magic of config is this function. All right, let's check it out. At this point, I'm all for merge. So this is taking one config and merging it with another config. Wait, where's the... crap. And so location also needs to go. Because location is config specific, right? Creates an empty config, adds them with merge. Well, I mean, I think some of that stuff is useful, but I'm not entirely sure how it solves like the current I'm not entirely sure how it solves the current problem. Right, yeah, so this is like if you were going through like a config directory and kind of like building up a bigger config. So I get that part of it, but I'm not entirely sure. I guess I'm not drawing the connection with the current thing we're trying to do, which is like this API server could take in one of many different unique configs, and we need to figure out which one it is. So you're saying this would be the config, and because the config doesn't really care about an explicit type, that we would just use that? I guess so. Can we do that? Okay, so let's try that. Let's try that. Because then in theory I don't need all of this crap, right? I'm gonna back this up. Let's just throw it up here and I don't know, what do we want to call it? Temp. All right, I'm just gonna save this here because that took a little while. Okay, so now what I'm gonna do is, I don't know what that is. You're gonna go away. ACI. Okay, I forget what I put in a cargo lock file. I don't know. Here's what we're gonna do. We're gonna just reset the crap out of this. Okay. So now let's rethink the problem. I like where you're going here. I have no clue why I did not consider that from the beginning, right? We're literally already doing this for we're already doing this for the input type. Why can't this be the config, right? I don't know what do we want to call this? A default config? I don't know. Config. Okay. Generic config. I don't know. That sounds good. So, but here, URI can be generic config, right? Test can be generic config. Fake can be generic config. And then we might have WebRTC. And WebRTC would be a okay. I don't know why I didn't think of this to begin with. that is like so much better of a solution. So now we would have a WebRTC config, right? Oh, your mom's sick? I'm sorry to hear that. Well, hopefully she has a speedy recovery. Okay, so here... Wait, what is this? No field audio or type on input config. Oh, right, because this is... Yeah, okay. So that's fine. I guess we should do that refactoring first before we start introducing all of this. So we are working on, the bigger project is an RTMP switcher. So basically what we want to build is we want to build this thing that runs somewhere in the cloud, and we want to be able to have multiple streamers pushing their stream somewhere, as well as videos, and we want to be able to pull from those streams and create videos going out to our outputs. And we want to be able to like trigger over HTTP to switch from streamer 1 to streamer 2 and back. We want to be able to do picture-in-picture. We want to play videos and all of that kind of controllable by a scheduler. And so we have a working proof of concept now, but the goal for today, what I was hoping to work on was to get WebRTC working so that we could use WebRTC as an input as well as an output. But the idea of working on all of this kind of created a situation where we need to do some refactoring, because up until now, all of our inputs and outputs could share configuration. But now we're in a situation where based on the input or output, they may have their own unique configurations. So we're trying to do a little refactor now for that. Okay, so so we need to fix all of these things. Okay, so what is this? The mixer. I'll fix you in a second, but let's just go through our individual inputs. So here, we need to change this to a super generic config. And same thing here, right? You know what? I'm going to change this. So we should be able to just do this. Use super generic config as config. Okay. That's the easiest way to do this. Then we can do input test. All right. And then input fake. Okay. That should fix a bunch of our issues. Okay. Okay, so the mixer one we're going to have an issue with, right? Yeah, so, okay, so we still need to fix this issue. And that is that Okay, so this is everywhere where we're like trying to create things. So I'm going to ignore these. Let's just work our way down. So on HTTP input, not a struct variant or union type. Okay, that's fine. So HTTP input, was it input config. No, where was it? 71. So this is, I mean, this is going to be a decent, all right, so input, so this is generic config. That's what we want as that. All right, so this is going to be all the tests, right? All right, let's just look for them. Create test. So, no, that should be fixed, right? Oh, no, because all of these create things here, right? Each one of these actually needs a generic config, needs a generic config, needs a generic config. Okay. All right, these ones we're going to come back to because we know what our issue is there. Oh, right, because this function... Wait a second. Oh, right. Okay, so this return type. Okay. So, input mod line 160, right? Okay, so for now we can solve this by just returning back a generic config, but we're gonna have to fix this later because we're actually gonna get rid of this method altogether. Now that each thing could have its own config, we don't want this. Okay. Now what do we have? Can I find derived macro deserialize? Okay, so we are just missing these inside of WebRT. I keep forgetting I haven't committed that one yet. So input, it's not showing up in there. Okay. Okay. All right, we're getting closer. Result re-imported, right? I mean, I guess we really need to... All right, let's fix this, because really, they're both in here. Wait. Yeah. So we just need GST create element. GST create, there we go. And then after all of this, we get to refactor the outputs to do the same thing. All right, so mixer mod line 106. Oh. All right, mixer mod line 106. Okay. So this is, we really want a generic config. Okay. And really I should probably like bring these into their packages and make them separate and then alias them or something. But we'll get there. Okay. So this solves our immediate issues. However, now we're going to have the issue where we're going to go into input mod. And now we need to introduce our new WebRTC type here, which is going to break more stuff. So we need WebRTC. Okay. Why is that up there? All right. Oh, it's ordering them alphabetically. I was like, why is that up there? Okay, so we're going to need one for our WebRTC. Oops. Oh, you know what I should have done? Well, yeah, we should have fixed the HTTP logic first. Yeah, let's do that. Because I want to make sure that works first before we do this. Okay. That should compile. Okay. So the one thing we need to look at now is we have like this create request here. However, what I think we probably want to do is what we probably want to do is actually return back a an input config, right? Maybe that won't work the way we thought it would. All right. So this would be. I'm just gonna do a use crate input really fast. We'll clean this up in a second because I think we want to differentiate between this generic config and that. But I want to see whether we can get whether this will work the way I was expecting it to. Okay, so I don't think this is going to work the way we think it is. Or is it just because we didn't put deserialize on our config type? The hope is that if we do this, that maybe Warp can figure out which one of these enum variants it's supposed to be. But I'm not convinced. Oh, cool. Musin, my warp expert here. I have spent hours fighting with warp. Hours. Okay, so how do I get Rust nightly? Rust nightly. I'm imagining I can do it through Rust stop, right? Rust up install nightly. Rust up install nightly. Okay, cargo watch plus nightly. Oh, it's cargo plus nightly. Is that? Okay. So, before I guess I get too far down this path, maybe you can help me with making sure this line of thinking is going to work. So, what we're trying to do is, now that we're trying to implement WebRTC, it's becoming obvious that our inputs and outputs can't share the same config. So what I'd really want to do is be able to have different JSON based on which input type. So what I'm trying to figure out how to do is be able to have this be dynamic, which type comes out of here. And so I went through this whole like trouble of like using Serday to like just pull out this part and then take this and then figure out which type to unmarshal it into after. But then Potatoes just mentioned that maybe I could just use an enum. Okay, so that still didn't. Oh, right. Because now input mod, input add, wait. Maybe this is right. Filters. Wait. No, because input add should be there. So it's saying it should be string input config. Found signature string HTTP input request. Okay, right. Okay, so that is here. Add, right? Because really this is now going to be, wait. I do have input config there. Okay. So input config here. And now we're going to have to switch on this. So now I should be able to map on input. Or no, I should be able to just match on input now. Wait a second. Okay, so that's there. So now I should be able to, in theory, just match on input here, right? Input, fake, input. Well, I guess you would have config for each of these, right? Wait, no, that's not right. It would be input config URI, right? Config fake. Config test. Okay. And then each one of these should have you can set up Rust toolchain to set a pin default Rust version for project, and Rust has a way to override toolchain just for a workspace. Okay. Expected struct input generic config found enum input config. Wait, what? Alright, hold on. Unknown field. Line 66. Wait, what is this complaining about? Yeah, they're still like really out of hand. Alright, so what is this one complaining about? Hold on, this may be left over. Yeah, okay. So here's our config. We're matching on that. We're looking for which config variant it is, and then determining which thing to do. Okay. So now we just have to figure out. Wait, expected struct input generic config found enum config. Why is it expecting anything there? Oh, wait a second, because this should be input. And I'm gonna have to like change some stuff around here. Because really it should be like generic input config and generic input config or something like that. No field location on, wait, what? Okay, so, oh, well, that's just a typo. Yeah, that's what I'm trying to figure out. Okay, so, wait a second. Does generic config have location on it? I can't remember. I thought it did. All right, it doesn't. So let's put it there for now. And no field name. Okay. Wait, what? Input name dot clone. No field name on type input config. Okay, so this is in the HTTP logic. As for layering configs, using a generic struct plus enum can be much easier to work with. Well, that's sort of what I'm doing now, right, is having an enum for the individual configs. Because the idea here is that this whole JSON document could be different per type that you submit, right? All right, let's copy out what you're saying here real quick. Are we about to reset the repo again? Okay, so let's see. So you're saying, so we have a generic config, and there's a type T in it. So here's the shared stuff, and then an enum for its kind. And then data is inside of it. Okay. Okay, I get where you're going here with this. Okay, okay, let's reset all of this again. Okay, so then we need to look at input mod. Wait a second. Why is that? Oh, get reset hard. Okay. What do you mean by inverting the structure? Okay, so instead of an enum with tuple struct variants, have a struct with enum fields. But wouldn't that... Because then I'd end up having a few of these, right? Then I'd end up having like pub, I don't know. What would that look like? Because there'd be certain things for, you know, WebRTC, for example. Like, I guess I'm not, I'm not thinking about what the enums would be. Then with generics, you compose more structs together, wrapping the other ones. I guess I'm trying to picture what you're thinking. Okay, so like a struct type embedding in Go, except a bit more verbose. Yeah, so that's one of the things I was looking for in Rust was like composing types. But I think I get what you're saying here. So if we had a type T, right? So, right, so this could basically hold generic data, right? So in this particular case, I could just do this or something, right? Because I don't really care about any additional data. So this is sort of what you're saying, right? So in theory for WebRTC, oh, you can default the T? How do you default the T? Ooh. Okay. So this would give me basically a default. So this would be everything I need here, right? And then do I need a URI? I mean, I guess the location would be it, right? Because really, you know, location string could serve for both URI and for like a file location on disk. So I think that this would be okay for like 99% of everything. And then, okay, let's get this compiling first. Missing data and location. Missing data and location. I guess also this could just be an option, right? Because we don't know that it'll exist. Which will just give you a config and you can specialize it for another T, but generally in Rust, the embedded in reverse via wrapping. Oh wait, how do I, okay, so then no, because I have to supply it always, so. So HTTP input on line 107. Wait a second. Line 107. I can't be in the right file. Oh, 71 here. 71. All right, so I guess here data would be none. All right. Oh, okay. Wait. All right. But generally in Rust, the embedded in reverse via wrapping instead of type A struct B, it'd be struct B, A, other A. And you do type aliases to give that T a concrete type. So type bug config goes. What's this? Oh, we're missing a comma here. All right. At line 71 here, we're missing location. All right, we're gonna have to mess with this. Oh. Yeah, so this is still gonna give me the same issue. Because config is a generic type, but how does the HTTP layer or Serday or whatever know, right? Because this config is going to be some generic config, right? It's not going to know what the type is. Which gives you composability. It's how Rust people sort of get around. Silent King, thanks for the follow. It's how Rust people sort of get around not having inheritance and other ways using traits. Yeah, so this still creates the same error, the same issue that I have. I mean, I like it from the code perspective, but when we do... Yeah, so that's sort of the problem that I'm facing now is how do I make this look different for each case without doing something like... It's funny, like, if I go this route, it means I could have saved myself hours. But... because I've been messing with this for quite some time. But, you know, the obvious solution, or the easiest solution, would to just be a hash map. You know, string here, right? But I hate doing stuff like that. So the JSON has to be modeled as an enum. Okay, so, well, that's sort of what I was doing last time, right? Where I was creating a config enum. Right. So that's sort of, you know, what I was thinking here. I just usually hate these buckets because then you don't know what values are going to be there. You don't know what values are required. You know, then you end up having to convert this to some other type later. Okay, I mean, I like that better. Just thinking. I mean, it's not as bad, I suppose, if I do it on the create request side, right? Because on this side, I could do all of the parsing and handling and ensuring things exist and stuff like that before I pass it into here. But on this side, I want them to have their own configs. This is going to be quite a bit of refactoring. is it a big anti-pattern to do that? To have a giant hash map like that? What's funny is like I could have had this done hours ago if I just went this route, but I was trying so hard not to do this. Value. Oh. If you have unstructured JSON, it's sometimes the only way. Yeah. All right, because I still have well, I guess options could, this hash map should also be an option, right? All right. Should then traverse and parse into two different types. Yeah. I was just trying really hard not to do that, but at this point, the number of hours I have spent going down trying to find a path to avoid it. We could have been doing a lot cooler stuff with WebRTC by now. All right, so that's an option. I guess, where's, no, wait. This is in the wrong spot. I keep putting this here. I don't want that here. I want it here. All right. I'm nowhere close to done, Werewolf Dev. So, yeah, I just sort of, I don't know. Missing location. Wait. All right, because I added that there. And I think I added name too. No. Whoa. We have a lot of clippy warnings. All right, we're gonna have to fix those at some point. OK or followed by a function call. What does that mean? Try this. OK or else. This is all in URI. Okay, it's in all of my inputs. Okay. All right, we'll fix it. Werewolf, thanks for the raid. Is that? Oh, that's why you were asking. Gotcha, gotcha, gotcha. Thanks so much for the raid. What were you working on? All right, so I'm gonna fix these really quick because they absolutely drive me nuts. All of the errors. So OK or all right, OK or else, and we need this to be a closure. All right, next. Oops. What's funny is I actually thought you were asking about like the project or the feature and not like whether or not the stream was over. I finished a prototype for a fun Halloween app called Monster, teaching myself Flutter and Dart. Oh, cool. I have not played with either of those yet. So welcome everybody to the stream. Welcome Raiders. We are currently working on an RTMP switcher, although I really need a better way of referring to that now because it does a lot more than RTMP. Impressive or not, I am currently working in WebRTC and ASP.NET Core with Blazor right now. Awesome. So The end goal for this project is, I mean, a lot to be used for conferences and things like that. But what we are trying to build is I guess we should refer to it as a virtual video switcher. So we want to be able to have OBS stream to multiple different endpoints, and we want our switcher to be able to go out and grab those and start pushing to one or more outputs. And we want to be able to trigger the switcher over API to say, switch from streamer 1 to streamer 2, and maybe have a scheduler do all of that. We also want to be able to play videos and maintain a constant feed here while we hot swap out inputs, add additional outputs, whether that's sending to multiple places or, recording to disk. We want to be able to measure a bit rate and things like that and fall over to pre-recorded versions. But one of the features I started 5 hours ago that we haven't got to because I keep fighting Rust and refactoring is trying to do WebRTC so that we can have a production view so that we can look at what the individual feeds are, like what's on each of these streams right now, and maybe even preview the output. And then the other side of it, we want to be able to have WebRTC serve as an input. So you could just go to the browser and also have the switcher grab your desktop or video and put you in here. We've got a working proof of concept of a lot of this stuff. It needs to be productionalized. We're working on the WebRTC stuff now. But we can do picture-in-picture and all kinds of stuff. You were calling that toString every time the code is ran, even if you weren't actually going to hit that brand. Oh, right. What do you mean, which provider am I using? Provider for what? Siphon and Lich, thanks so much for the follows. Oh, are you making your own stun server? Right now, we're just going to use existing stuff for that. I mean, if I need to, I will deploy something else. But for right now, we're just kind of focused on our side of things. All right. Fixing all of the compiler warnings. You're going to lurk? Have some fun stream? All right, cool. Thanks so much. Yeah, it's gonna be really cool once it's finally done. Okay, and then fake. Okay. All right, now I gotta remember where I left off. All right. So we ended up aborting mission and just going with options. Okay, so if you're doing a combinator on a result option and the error path does something expensive, you should then prefer else. Gotcha. I am using Linux. This is Arch Linux and i3 Window Manager and NeoVim. Okay. So here's our generic stuff. So now I guess we need to look into creating our, is this input mod? Okay. So now I guess what we really need to look into is our input WebRTC. Okay. Oh, thanks for the bits. Also using Arch Linux. Thanks for supporting the links, man. Yeah, I've been a Arch user for I don't even know how many years. I mean, if you subtract the 6-month stint I did as an experiment with using Windows for the first time in 15 plus years. Okay, so we're just gonna leave this here for now, but the one thing we want to do is we do have this config. And how do we want to combine that? Um, just thinking here. So we have the, oh, wait. That's right. We're doing options now. So we don't need that anymore, which means we don't need Serta in here. Okay. Okay. So I guess we can start looking at how to pull in. Oh, no. We need to introduce our WebRTC type into the input mod for like the third time that I've done this. All right. All right. Okay. WebRTC. Okay. Let's go implement all these on the enum. Well, I mean, I guess we should do this. Okay. As for the hash map approach, if you have a semi-type JSON, you can use any type as a key or value in a map, as long as the key implements hash and equal, which are... Okay. Wait, why is that complaining? Oh, because it's going to return back a WebRTC. Right. Okay. WebRTC. WebRTC. I kind of think that this should go up here. Let's move this up here because those are the types that are going to be used the most. So same thing. I'm going to move this up here. Okay. So say you have an enum v a b c unknown string hash map string v pseudo. Okay, so you could actually have an enum for the other side of the hash map. Okay. So in theory, I could have the individual like configs that are specific be variants of some enum there. So have like the shared part in one area and then have another field or something. Okay. WebRTC. WebRTC. Okay. Is that it? Oh, wait, nope. I don't even know why I have these done this way, right? Because almost all of these, right? Like, can I just do this? Right? Like, so many of these are like basically the same thing, right? So same thing with name. Wouldn't this just, can I just do this? Does that work? Or do I have to do a giant or? The name one can be shortened. How do we shorten that one? Is it just input underscore? Like, what's the shorthand for that? Oh, right, yeah. So that's sort of what I was thinking. So I mean, it doesn't save a whole lot, right? It would just be each of these variants, right? Input, WebRTC, input, right? You can even rename fields so to match other bindings to type in the bindings. So does it really matter if I do it this way though? I mean, it doesn't really save that much, right? Fake. Input. Input. Test, right? It doesn't really save that much. You can use input. Oh, right, yeah. I kind of feel like that's cleaner. Okay. Okay. Oops. What's funny is I've probably done this like at least 3 times today in all of the various refactorings to avoid doing exactly what we're doing now. Oh, and you didn't know you could import variants like that? Right. That way config will give you the inner input if they all have it. Okay. What are we missing now? Config not found in this scope. Oh, because we input fig, right? Because we removed it from here earlier. Alright, we'll worry about fixing that the errors or the warnings later. Wait, what is this one? Input. Oh, because gotcha. Okay or else. I keep forgetting about the okay or. But personally, if every variant has the same data, a struct plus enum is cleaner. Yeah, so I ended up using that enum at the top with types or methods on it as kind of like a because I wanted an interface, right? And I needed to be able to store that interface somewhere, which is just painful in Rust. Okay, so so now we have all of this laid out here really quick. So in theory, we should be able to start assembling a pipeline here. So I think I'm going to run and grab it's basically what he's doing. Wait, how about an infallible get input method that extracts it? Or I'm not sure I know what you mean, Siphon. I'm gonna go grab new drinks real quick, and I will be right back. And then we can start pulling in all of this sample WebRTC stuff. Be right back. Why do all of these snacks have to crunch? I'm like, oh, I'm gonna grab a snack. And then, yeah. Hold on 1 second. My kid's mom just called me a couple of times, so let me call them back real quick. Okay, now we're back. All right, let's see if we can get WebRTC working. Let's see, what do we got going on in chat? So all the getters just call the single getter. Sure, that's much better than deref to fake. Okay. I think you all are losing me in chat. Right, getters and setters have a single lifetime that is tied to self of the function call, while a struct can have n borrows, one per field at the same time, assuming you aren't borrowing the whole struct, what a getter does. I think I am completely lost on that one. Okay, so let's look at, oh, I don't know why I'm doing this. We need to go back up to GST examples, WebRTC, send and receive, and then GST Rust. No, Rust. There we go. And then source main. All right, so this is the one we're going to use for reference. So we need to find the pipeline for... Okay, so this is what we're sending, which is not the side of it we want. We actually want... We want the opposite side of it, which is when we get a connection. Okay, so here is where I think it is. Wait, no. All right, I guess we need to understand this code a little bit better. Also, one day I'm gonna have you all help me understand the difference between like weak references and things like that, where you upcast and downcast these things. I'm still not entirely sure what that means, or upgrade and downgrade rather. Okay, so now I'm trying to remember all of the lovely stuff we read about WebRTC earlier. So let's try and find it all here in the code. All right, so this is our WebSocket handling logic. And this is just pipeline messaging. All right, so on negotiation needed is, I remember, is called right when things start up. And we need to create an offer there, right? So tells us renegotiation is needed. Simply ask for a new offer from WebRTC bin without any customization, and then asynchronously send it to the peer, right? Okay, so that part of it we understand. So the first things we're gonna have to look at is, we do know that the first thing we need to do is handle WebSocket logic, right? So let's start a little to-do here at the top here. I guess here's as good a place as any. So to-do for WebRTC input. So the first thing we need to do is connect to the WebSocket, the signaling WebSocket, right? We need to create and send offer to WebSocket. Down the row, we need to handle offers from other peers. And then we also need to whatever we're doing with turn and stun, right? CM Griffin, thanks so much for the raid. I guess I would have assumed you were done way earlier. Well, I guess I've been going. Yeah, I've been going a long time. How was the stream? I did end up streaming. I decided I really want to get this WebRTC stuff working. So I decided I was just going to get on and do it. So my learning about WebRTC was about, I don't know, 10 or 15 minutes of learning about WebRTC, and then several hours of bashing my head against the desk while I refactored about 16 times. Angjatina, thanks so much for the follow. Was it Ian Alex Hart? Thanks for the follow. It was good, made some progress, and have the WASM parsing C#. There may be a hack or two to fix properly. Yeah, I feel like I've been leaving a lot of those. Shorty B, thanks for the follow. So everybody who's new here, what we are working on is an RTMP switcher. I call it an RTMP switcher because that was its initial goal. However, it's turning into kind of more generically a virtual video switcher. So if you're familiar with what a production video switcher is, you would typically have a bunch of HDMI or SDI inputs, and those would be like your cameras, and then you'd be switching cameras. You know, go to camera 1, go to camera 2, and it'd be going out to some other output. So we're basically trying to create like a web-based version of that, where your inputs can be RTMP streams, which is what OBS is pushing right now, or videos. And the thing that we're trying to play with now is getting WebRTC to come in as an input so that we could pull you in. And we've got a diagram here. So basically we could switch between, live streamers. We could do picture in picture. We could fall back to video, things like that. We want to be able to hot swap inputs and outputs and resize them and all of that good stuff. I am happy to do a demo for any of the folks that are new here and would like to see a demo of it. We can also walk through how video switching or video streaming and adaptive bitrate works as well. Rust does get easier once you learn patterns and how it's possible to structure data. Yeah, that's the thing you find is a lot of the idiomatic stuff. Yeah, Wayne's World, camera 1, camera 2. I'm just here for the light show. I thought I followed. Cheers. Yeah, so you can actually control all of the lights as well, right? So we have party here. Wait, is the bot broken? Hold on. Wait, what is going on with my bot? Burnt Toast and Death by Cheeto, thanks so much for the follows. Wait, what is going on with the bot? Oh, there we go. There's party. Mute music to hear bugs better. Yeah, so does anybody want a demo of where we're at? I mean, I'm happy to do that. I know we have a bunch of new people here. All right, so we've got all the turn and stun magic. Okay, so here's what we're gonna do. We run the app. I've got another computer over here. So you're gonna see me lean over here for just a second, and that's mainly so I don't overload the crap out of this machine. I'm going to start broadcasting a stream from here of a video off to an RTMP server. Okay, now we have video going. So what I'll do here is I'll show you first. This is just a live preview. Wow, what is going on with my internet? Ooh, I wonder if this is like an Azure issue. Is it an Azure issue? Or is like my... Let me try a different one. Interesting. So there's something going on here with these containers. Let me see if I can restart them really quick. Although I'm fairly certain that, I mean, they've been running forever there. All right. There we go. You know, this is the way things go. Whenever you go to demo something is when it breaks. All right, so let's restart that one. And let's... Wait. Restart this one too. They've been running for I don't even know how long, a month? Okay, we'll give those a second to load, but basically, well, I guess we could also do it locally too. So we're gonna add a mixer, and a mixer is just where all of the inputs come in, and we mix together the audio and video and stuff like that. So being that we don't have a working output, we're just going to send it to my screen. So we're going to create an output type of auto. And you're going to watch. I keep forgetting because we haven't made this generic yet. Location, nothing. All right. So that's just going to pop up this screen here. And we're going to have to get rid of all this. So now we're going to send a video to that stream. So that's all playing there. I need Big Buck Bunny. Well, now it's failing because of restarting. I have the feeling that this is actually an Azure issue, which is kind of embarrassing. All right, let's get Big Buck Bunny somewhere. Big Buck Bunny, give me a big video. Standard. What format are you in? Are you in MP4? All right. So let's see if we can take this video. And we're going to stream this one because then I'll show you kind of what's possible with this. So we'll add this one. Oh, I killed it. I killed it. Okay. Add a mixer. Add our output back. Then we're going to add this one. Okay, so now that's all playing, right? But what we can do is we can now update this input. And we're going to resize it. So we're going to make it 760. We're going to make it 768p. Give it a little alpha transparency so it blends, change its X position and Y position. Wait, not found. Oh, I think we named it Sintel. There we go. So we can move this all around. We can change its size. If we went back here, I guess we could change its Z order intentionally to Z order. So we're going to set this to something like really, really high. Okay. And now we're going to back up here and we're going to add this one behind. Oh, wait. Sintel 2. Okay. So we can do this with like videos everywhere. We can do it with RTMP. And, you know, we could update this again and I don't know, change its Y position here. And
a dangerous quest for unknown hunter.
I've been alone for as long as I can remember.
so that's sort of where we're at now. We've got a lot of like productionalizing things to do still, you know, to stabilize everything. But we can do this with RTMP feeds and stuff like that too. Is this still restarting? Yeah. Okay. We're going to leave those alone to restart for now because we can preview this locally. So one of the things that we're doing right now is we're trying to play with WebRTC so that we can push the video out to WebRTC for previewing or pull video from WebRTC to inject in our feed the same way you just watched those videos get injected in there. So we're trying to create the input pipeline now for WebRTC, but WebRTC has a lot going on with it. So we need to first manage the signaling WebSocket to communicate through, because both sides need to connect and do some negotiation through the WebSocket. And then we have all the turn and stun and connectivity for the actual peer-to-peer. So that's sort of what we're looking at now. There's this like working example that I did find. Actually, I mean, we can show that off here. GST examples, WebRTC, send and receive, GST Rust. Okay. Oh, wait. So I need to do this. Peer ID equals. So if we come here, we can grab that peer ID, 2167. So there we go. So you see us sending the ball and the browser getting my camera and microphone and sending it back to us. So this is sort of like just a working example of using Rust to do that. Now we're going to try and take this example code and turn that into our pipeline, being able to grab that. So I need to find the server logic here. Not that server, but this server. So this is the thing we're concerned about it connecting to, right? All right, so this tungstenite, I'm guessing that is some sort of crate that they're using for doing WebSocket connections. Okay, and so what this looks like it's doing is it's sending just hello space and some unique identifier over. Okay, that's exactly what I thought. So I guess that's the first thing that we should do is probably pull in we're going to use tungstenite too then. Here, async tungstenite. It's a Tokyo async standard geo, etc. async wrapper around it. Okay, so which is what Warp is using too, right? So cargo, toml. Okay. I should be using either that or Tokyo tungstenite. The async one is a new. I still wonder what's going on with these things. Those things have been running rock solid for a month. The one you're using that is async standard, you can pick the runtime via feature flags. Okay, that's what this is doing. All right, so there's that. So I guess the first thing we need to do is manage our WebSocket connectivity, right? So this is going to be really interesting to manage. We're going to have to create some sort of thread here. All right, let's look at our WebRTC logic here. So obviously we're going to have to manage a couple of things here. Well, it's the servers and stuff are there, but we're going to have to track our WebSocket here. So WebSocket is going to need to be here. And then I guess we're probably going to have to manage our peer connections here as well. We're going to need our own peer ID. Although we could probably send that in the config. Oh, how did I get here? You were dragged against your will. We showed up. We covered your head in a bag, threw you in the back of a truck, and now you're here. Okay. So, these are a few things here. I think the most complex part of this is that we are going to have to create a thread somewhere. Because we need to manage this WebSocket connection, right? What are they doing? So this is just, this looks well, I mean, they're doing the await here, but it's effectively synchronous, right? They haven't spun out a thread yet. Here's the message loop. Okay, run. That's what we're looking for. If it's async, you can just Tokyo spawn like a go routine, sort of. Okay, so here's run. Takes in the arguments, one of which is a WebSocket. Splits the WebSocket into the sync and stream. Okay. And this is where it like spins up the application. Okay. I don't know what fuse does. But it looks like some sort of iterator. Alright, so now we're looping. And there's like a select statement. Okay. Just spawn async move, foo, await, bar, await. Async iterator. Okay, yeah. And then we're selecting on that. Select next sum. So we're looking for the message, whether we get a close, a ping pong, binary, or text. So we only seem to be concerned about text coming across here. Okay. Pass the GStreamer messages to the application control logic. I'm not sure what the handle pipeline message is, but we'll look at it. And then handle WebSocket messages we created asynchronously. Is such a futures RS-ism? Okay, so this looks like it's all handling logic or messages that are coming in. All right, so WS stream must be, okay, so those are messages coming in. WS sync is messages going out. What does fuse do? Oh, wait, okay, so each iteration of the loop, we're trying to read messages coming in. Does select block until something happens? Or does this complete and it's the next iteration of the loop? Well, I guess WS message in standard iterators can be fused, which means once it sees a none, it won't have its next called again. Okay, so none effectively breaks the iterator. Okay, so, but which, I'm confused, are each one of these? Oh, right, they're comma separated. So each one of these is a future that it's waiting on. So we're saying if it's able to select one of these messages, wait a second. This is just interesting. Oh, because this is a macro. I'm like, this is just weird logic. There's no let here. There's no, it's because it's a macro. So, okay. So this is one potential path. This is another potential path. Then, okay. So each one of these is a potential path. Okay. So we're saying we're waiting for one of these messages to occur and then doing this particular logic. If that happens, if there's a GStreamer pipeline message to yeah, okay, yeah, okay, that makes sense. And then this is after. So this is just basically each iteration of the loop. We are also checking to see whether we have a message. Where's WS message? So does WS message live after this select? Oh, because whatever's returned from this is stored in WS message. Okay. So then if there is a WebSocket message in there, then we're sending it. Okay. So each one of these is basically waiting for one of these to... checking each one of these branches, doing its thing if that's the thing that comes up. Each one has the opportunity to return back a message that it wants sent over the WebSocket. I feel, okay, right. So if it's a GStreamer message, it's saying nope, right? So here, nope, nothing is returned back. If it's a ping, then we want to send back a pong. Okay, yeah, all right, this makes sense. So, and then basically at the end of this, this is just basically, does it need a response? And then we're sending that. Okay. So we basically need this function. Well, we need the connection function first. And then we need to basically recreate this whole loop, right? Ooh, this is actually a really good idea too. To have like a master list of the plugins that are needed. Macros in Rust fragile? I've not seen that yet. People do a lot with macros in Rust. I have noticed that. Okay, so how do we want to handle this? Is a different kind of macro? Yeah, there's a couple different types. I did notice that. Okay, so how do we want to do this? How do we want to do this? I guess the idea here would be that I guess on the create, would that be the best place to do the thread? And I think we're already doing a Tokyo spawn, aren't we? Somewhere. Okay, so oh no, we're using standard thread there. All right, where's Tokyo spawn? Tokyo spawn. Oh, right. So we just passed in a closure and we need to do the async move on it, right? Okay. So we're gonna need this. Let's leave that there. That's probably gonna complain about. Well, we don't care about that, but we're gonna need to pull in some of this stuff, right? Okay. So I guess the first thing we need to do is connect to the WebSocket. So let's borrow this here. I'm just going to do this inline here for now. And then we'll pull it out into other functions. So, well, I guess really all of this can be done inline. So let's, all right, I lied. Maybe we should just have like a connect function here first. Because this is going to get a little kind of crazy here. So, I guess this doesn't really need to be on the type, does it? So I could just do a, like a function async. Wait, is it the other way around? Async function? Yeah, async func, ws connect. Okay. And then, I'm going to use this for now. I don't know what I'm returning yet, so we're just going to start here. Hey, Hacker, thanks so much for the follow. Okay, so we're going to use this as our starting point, and then we'll adjust what the return values and stuff like that are as we move further. Okay, so let's call that server. Okay, so this is going to return us back our WebSocket. Maybe that's what we should be doing. Maybe we should be returning back a result. What value is that? What type is WebSocket? Tell me. I don't know. I guess I can do this and let the compiler yell at me and tell me it needs to be something else. Okay.
What you're going to hear about today is nothing short.
Okay. WebSocket. All right. There's an unsolved CS problem standing in its way. Okay. So this is what we're looking for. Async tungstenite WebSocket stream. That is what we are going to return.
Sound waves reaching the microphone are changed into impulses of electric current.
Okay.
Tremendous new musical experience can have.
Cannot infer type. Why? Expected one type argument. What am I missing here? Oh, for this you definitely want to use Tokyo runtime for the WebSocket, so it'll work with Tokyo spawn. Oh, WebSocket's a generic? Okay. Raimu, how's it going? What am I doing? Well, run. Where? What do they have it going as? Oh, it's some sort of trait or something? Ah. So, well, this one's pretty easy, right? Where I could just do, right? Well, I mean, I guess it would be async tungstenite, right? Async tungstenite WS error, right? So, but I think that it's because this is like some sort of trait or something.
It's available for everyone.
Wait, unexpected type error. Whoa. Use async. Am I missing something here? No, because the original methods worked. It was only when I tried to return the type, right? So I gotta figure out what to put there. I still don't know what the issue here is. This one is because I'm not supplying what the type is. I just have to figure out what that is, but I'm trying to figure out why. Cannot satisfy standard convert from tungstenite error. Oh, so this isn't a WS error, it's just an error, right? Okay. So now I've got to figure out what type is coming back from here. You should be using... I don't know what runtime I'm using. Tungstenite, runtime. Oh, I got you. This placeholder. That's what you meant here. So that's what I'm using, async standard. And you were saying I should be using something else? You want to definitely use the Tokyo runtime for the WebSocket. I guess I need to look at how I do that. So async tungstenite LSP does not like this at all. Okay, so Tokyo runtime dash, which will give you async tungstenite Tokyo. Yeah, completion's not working at all here. Tokyo. I got it to work with async standard, but I guess it works for both. Okay, so that's still expecting the type error. So I have to figure out what that generic type is. Well, he's using warp, so it makes sense to use Tokyo, yeah. Okay, so I'm guessing that this is fine. I just need to figure out the type, right? I need to figure out what that type is, though, right? You need to add I thought feature flags were there, though, weren't they? Like I've got... Oh, no. Tokyo... So I need Tokyo runtime. They were the standard ones there. I gotcha. And Tokyo native. Tokyo native TLS. Okay. The type is stream, which has two variants, plain and TLS. Okay. I don't know whether this is going over TLS or not. So I guess I can just say, Tokyo connect stream. Unexpected type argument. I'm so over typing. All right, so we're missing something. Cannot infer type. Cannot satisfy standard from tungstenite error. Wait, okay. Wrong number of type arguments. Expected 1, found 2. Oh, because this is my result type, right? But this is still not going to be able to convert from that. So yeah, so this is why that's complaining. Not found in Tokyo. Oh, wait. This is async tungstenite Tokyo connect stream, right? If I recall, you have your own result alias. Yeah, I do. Okay, yeah, so the trait from is not there. Okay. So, right, like I could just do a dot map error, right? Is it better to map error or to implement from? Yeah, I was just trying to see whether this works really quick. Use of undeclared. Wait, is it mixer error? Mixer error. I'm just seeing whether this solves our issue. And if so, then I'm gonna, okay, yeah. So that solves our issue. We do have some kind of warning. I think it's probably just that we're not using those. So let's go find our error package and implement something here. So error.rs. So now I guess we should so what was the error type that I was unable to implement? Oops. Okay, so here we go. So we need a from. Okay. And what do we want to call this? WebSocket? Okay. Did that work? That not work? Oh, because it's not covered in our HTTP errors. Right. HTTP mod line 78. Okay. Oh, right. Yeah. Okay. So okay. Okay. We're getting closer. You go away. We still need you. We don't need you anymore. We still need you for reference. Okay. So now, in theory, at this point, we have connected to our WebSocket. So we need to send our hello command to negotiate with it. So I'm just going to copy all of this fun stuff because that's what we need. Let's double check. All right. So what was our tracing info? Tracing info. Okay. Oh, all right. So we need to import. Wait. Our ID. Okay, I'm going to use this for now, but I think what we should do is say to do if pure ID passed in config, use that instead. Okay, so because I think there's going to be a point where we need to ensure that we know what the peers' IDs are, right? Because otherwise we're caught in a situation where it's like, how do we negotiate that? So I think that we need to make sure that we know what the peers are going to be always. Map errors and yeah. If you don't want the from in your API possible outside of the function, it's the way of doing it. Are you talking about the from? Okay, so let's pull in this rand function because I still think we're going to use it, right? Wait. There we go. So I think we're still going to use this, but I do want to, there is the possibility that we may want to do something different. What are all these crazy errors? What is all this? All right, so some of these are missing things, but some of them are, I think, just all the WS message and whatnot, right? So we need these. It's the same thing code-wise. Map, error from is all question mark really does do the try trait and some other stuff. What is bail? Is that a thing? I don't think I'm using it anyhow, right? It makes to make an error and return it. Yeah, I'm not using anyhow. IR has bail too. I don't know whether is that something I really need in here? I think, yeah, all of this stuff, I think that I really just want to do like tracing, warn, and then maybe like return error. I don't know. Error, mixer error unknown or something, right? Yeah, so I don't want to do any panics. All right, so what is this complaining about? All right, let's pull in WS message and WS error really quick. Okay, yeah. We're gonna do this too. All right. Uncle Tony, thanks for the follow. All right, so Oops. Okay. Hello, Mr. Weestar. All right, so that one we know. Not found in tungstenite. Wait, what? Did I break something? Oh. Never mind. I messed that up. Because they're two separate things. It's actually importing tungstenite from acing tungstenite. Okay. I made my first small Rust test project yesterday. Awesome. Yeah, let's do that. As WS. Because this crap is just painful. WS. WS. Okay. Nope. Can't do that either because we're using it here. Alright. I don't think I have to type it that many times. Alright. Alright, I know that this isn't going to be in there, so let's fix that really quick. So 150, args, peer ID. Oh no, so this is the peer ID. So let's just call it, I don't know. Yeah. So peer ID is the person we're connecting to. So this is basically saying, tracing warn. And so how do we return from this though, right? So I'm gonna need to fix this one too, right? Because I need to know that this didn't return properly. Well, no, because I could just return back an error, right? All right, so this one is just this type being returned back here. Hold on. Let's figure out this one. What's happening on line 135? 135. All right, use of undeclared crate or module rand. Didn't we just import that though? Oh, because it's not, because that is a crate I am willing to bet. It is a crate that we do not have. Okay. I was thinking that was like a standard library or something like that, but it's not. Okay. Anyhow, makes an ad hoc error from a format string for binaries. It makes sense because you're not going to really check the error, just propagate it to the user. Okay. Cannot infer type for type integer. I'm guessing that the reason for that is just that we're not using it for anything yet, right? Yeah, so everywhere is just basically converting it to string and stuff. So I guess if we gave it a type of, I don't know, U32, that would fix our issue there. Okay, so here, Fun fact, Rand was in the standard library. Its commit history has had the full Rust C commit history. Wait. Huh. Apparently random numbers are hard. All right, so I know this 150. There we go. Let's just do peer ID, right? I'm just gonna put string here. Okay, so I'm just gonna do that. Oh, that's not gonna let me. Boo. All right. So I guess we should just do this. Our ID string. And then I'm gonna say because I don't think we actually need a U32 there. I think it can be anything we want it to be. And I think that we should probably have some sort of naming convention for it or something. So I'm going to use that as a string. Well, you know what? We'll convert it later. All right. So our ID is U32. And so I'm going to say let our ID equal well, no, I guess it would be an option, wouldn't it? Option. Okay. So here we can basically just match on our ID. We might as well fix this now, right? So, okay. If we have some ID, then we're just going to return back ID. If we have none, then we're going to return back this. So now this handles the case of generating an ID if we haven't like given ourselves one. Okay, perfect. So now what's next on the list? Line 142. What's going on with you? All right. Method not found in async tungstenite. Oh joy. So it looks like maybe the Tokyo side of things is different. WS dot. And I don't have that. All right, let's find the type. So it's not found in async tungstenite WebSocket stream. The method is available for standard box WebSocket stream, async tungstenite stream. Wait, what is the difference between these things? So if we box it, it's somehow there? All right. I'm going to copy these both out of there because this is slightly confusing. Okay. So this is the one that says it's not available for, but it is saying that it's available for a boxed version of it. So I'm going to remove the box and let's see. So they're exactly the same aside from use Tokyo stream extension as. Oh, see, these are the types of things that I think make Rust really, really hard to adopt for like newcomers, because honestly, like this isn't the like first time something like this has happened either, and like the error messages don't really lead you into understanding that that's something that you need to do, right? Still not found. You're missing send. It's sync extension. No. Use Tokyo stream. No. Well, it doesn't look like there is this. Oh, so it'd be sync. No. No. Tokyo doesn't have sync in it. All right, so this is getting a lot more confusing. Are you sure we shouldn't have used standard? Okay, so where do I need to get send from? So futures RS is the canonical set of traits types for futures. It provides... Okay, so let's see. Do I have futures RS installed? I do not. So let's go check out crates. Crates.io. I kind of feel like I'm developing through Stack Overflow right now. All right. Okay. Tokyo, etc. all use the futures crate, but some don't re-export sync because it's tedious. Okay, so then we should be able to say use futures. No. Nocturnal Chic, thanks so much for the follow. What am I missing here? Why is that not working? Yeah, that's what, but I'm not getting completion, so that kind of makes me wonder here. I mean, maybe LSP just hasn't caught up or something, I don't know. Futures sync extension, okay. What are you blocking on? Oh, there we go. No sync extension in stream. Oh, did I forget to remove the other one? Yeah. Oops. My bad. I don't use that trait if it's not obvious. I know all about it, but it's such an... All right, let's see. Is send fixed? Send's fixed. Okay, so now we just have to figure out this whole thing. So, okay, or else. Oh, I'll need stream extension for next. Okay. Stream extension. But so these are the types of things, though, I think are really, really difficult for people coming in, though. Like if I didn't have you all in chat, like recognizing these errors and be like, oh, you're just missing this trait you need to import, the likelihood I would have ever figured that out, like I would have just been like, nope. I would have just noped right out of it. And so I think like the compiler itself is really helpful, but when it gets into kind of the way things are designed around like macros and traits, some of this stuff gets really confusing really quickly. 157, let's fix that first. All right, so, oh, I guess peer ID also should be an option, right? Option. Okay. And here we should basically just do that. Okay. That having to do a use to get a trait is on my not my favorite features list for us. Yeah. They did a great job at portability, extensibility, and making it mostly just work, but when the helpful compiler loses the abstraction, it gets crazy. Yeah. And I think that's the part, like in the beginning, like learning Rust and going through some of the tutorials and Rustlings, I started to get like this false sense of confidence, like, oh, I get it. But now that I'm starting to use some of this stuff like Tokyo and Warp and all of these things that are like really heavily macro and trait based, it all starts to fall apart and you like sort of lose your confidence in your understanding of things and where to even begin to look to solve your own problems. Okay, so this one's pretty easy. We can say tracing error, right? Okay, and then we're going to return back. I guess I'll just do the same thing here. You know, I'll slowly change all of this stuff and productionalize all this, but for now we're trying to get working prototype. Okay, so I need to get rid of this anyhow. Well, okay, or else I should be able to return back something, right? So I should be able to say mixer error unknown here too, right? Yeah. I agreed, but when it works, it feels good. Yeah. Yeah. No, I love the language. I mean, don't get me wrong. I do love the language, but you know, I'm at that point now where I can get around and do stuff and I can kind of build stuff with it, but then I run into some of the stuff and it just all falls apart for me very quickly and I don't even know where to begin to solve my own problem. Okay, let's see. Oh, we're still missing one. Okay. So here we're going to do the same thing. Mixer error unknown. Okay. All right. We'll make better errors for these things, but for now. Okay. A couple of process killed them back. Okay. So now in theory we have a WebSocket connection. You know, hopefully by this point we have a WebSocket connection. We have said hello to our server. We've given it our own peer ID. And then in the event that we're asking to join a session with a peer, we will pass that session ID to the server. Okay. Sounds good to me. So that part's done. So now we have to worry about like kind of like the whole create offer, send offer thing. So this is returning back our connection. All right, so at this point is where we're spawning our okay. So here's where it moves into run, right? So this is where we need to like do all of our heavy lifting. All right, we're just gonna copy this all in just as it is. All right. Okay. So we're gonna find some stuff. I don't even know what all this crap is. But we'll work through it a little bit at a time. Same way we did before. I think it might be okay to just leave it all. Shoot. Well, I guess we're gonna have to figure out some issues. Well, no, how are they handling some of this? All right, so this is gonna be interesting to figure out how they're handling it. Maybe we should walk their code first. Right, because we got a brief understanding from like an abstraction standpoint how things were being handled. However, it's not entirely clear how we are communicating with the GStreamer pipeline. So we've got like this handle pipeline message. I'm very curious what that does. So let's go find that. Handle, and I'm curious what their app abstraction is being used for. Okay, so here, okay, so this is GStreamer messages, right? All right, I want to look at what app new does. What does app new do? All right, so it's returning back a tuple of GStreamer messages and WebSocket messages. Okay. But the other thing that it's doing is creating the pipeline. But up on the upside, they are aware of the usability problems and are constantly improving the situation. Yeah, and you know, languages like Rust and Go and all of these, Zig and Nim and all of these are, you know, relatively speaking, are very, very new, right? Oh snap, Slick, I had to build a web conference system for a client at work. Nice, what did you end up using? Oh, and you use WebRTC? Yeah, so that's similar to what we're trying to build. Except, you know, WebRTC is just one of the many inputs and outputs that can potentially exist. Okay, so this is creating the pipeline. Okay, oh, wow. Okay, so this is where all of the craziness exists. So new, where's that end? It's like 100 lines. Okay. Instead of pushing out something half-baked, they're totally fine with waiting until it's solid. Yeah, and you should, right? Like, most of the languages that have gotten really crufty over the years are due to rushed features, right? Somebody getting excited and being like, oh, look at this feature in this other language. We need that too. Yeah. Musin, can you help me out here? What is downcasting? Okay, so here we're generating the bin. We're setting some properties on it. Okay, so this is the pipeline. And the message is on the pipeline. Okay, so this MPSC is basically a channel, right? Yeah, channel for outgoing WebSocket messages from other threads. Oh, this one's going to be to cast the type to another more specific type. Oh, I get you. Upcasting, you're getting more and more abstract. You're moving up. Okay, connect to on negotiation. Gotcha. Okay. Yeah, and then there's downgrade. Okay. So some of this stuff we could actually... There's a lot of this we could probably copy over, right? We just have to kind of figure out where that is, right? So right now, the white, it would probably be primarily 1-to-1 at the moment. And the reason for that is that the current problem that I'm trying to solve is I want this video switcher that I'm building to be able to have a preview where I can see what's coming in on each input and previewing the output. And I also want to be able to have somebody go to a web page and be able to be added as an input into the outgoing feed, either through picture-in-picture or through like going full screen and manually switching and things like that. So that's the current goal, but I mean, multiple peers could be interesting in the future. So here's something that I'm trying to think about as well. Right now, okay, so each having their own RTC peer connection. Yeah. Calmac, how's it going? So, I'm just thinking, right now, I'm building all of this logic here. However, this needs to be shared somewhere. I need to figure out how to abstract this a little bit, because we're going to be using this for both our WebRTC input and our output, right? So in this particular case, everything else is the same. Everything else is going to be the same. The only difference will be whether or not we're sending our stream to, like, connecting to a pipeline to send data out to them and into them. So now I almost wonder whether there should just be a WebRTC type something like this, like a WebRTC app or something like that, that we leverage. Because the idea would be here that we need to just spin up one of these on each side, right? What is the scheduler for in this diagram? That is basically, I actually have a coworker building this. So this would be so that you could load up a calendar of events and say, you know, this person is going to be live streaming at this time, this person at that time, as well as like, well, you know, at this other time, we want to play this video, and you could load up a playlist of things like that. And the scheduler would basically based on some sort of calendar of events, live switch, you know, we know Tuesday at 1 p.m. streamer 1 goes on. So we spin up this RTMP server for them, email them a stream key. And then, you know, 2 p.m. we do the same thing here. And then, you know, at 2 p.m. the scheduler says, okay, switcher, you need to switch over to streamer 2. Q3, thanks for the follow. Okay, so so this is sort of what I'm thinking. I kind of am starting to wonder if I'm starting to wonder if we should have some sort of just WebRTC library that is reused. Because there's a lot of places we're already doing some copy and paste magic here. And so all of the logic is going to be extremely similar. It's just going to be when we make the peer connection, are we going to send them data or not? You're doing the same thing. You're building the scheduler. As for downgrade, that's an ARC RC thing. It downgrades to a weak reference. And then you have to do an upgrade to get the real thing. Okay. RW Grimm, how's it going? Yeah, so there are WebRTC sources and sinks. So that's actually what we're using. And in this example, you can see they're using WebRTC bin as part of their pipeline. So what we are working on, though, is all of the other logic, which is basically the signaling that takes place over the WebSocket and the stun and turn logic and all of that craziness. Because we still have to basically get our hooks called whenever negotiation's needed or whenever we get a candidate and all of these things. So we have a nice working example. Now it's just a matter of taking this example source code that we found and marrying it to our architecture. And I started, I kind of have, make sure you put auth on turn. Oh, yeah. Yeah, so I have all of like these inputs and outputs kind of broken up. And they all kind of have like their mini pipelines in them, so they kind of just work. So that's sort of the abstraction I built. So I'm working on ones for WebRTC, but now that I'm starting to implement all this, I'm starting to realize that like 90% of the logic is going to be the same with my WebRTC input as it is with the WebRTC output. The only difference being whether or not I connect, the video, right? I'm either going to connect and push my stuff and ignore the incoming data, or the opposite. So that's sort of what I'm thinking. But I mean, that would mean that I could probably borrow most of this code, right? Get rid of all the anyhow stuff. Maybe pull some of this stuff down. Guess what would that look like here? Because we basically need to just tell it to connect to the pipeline, right? I guess I kind of need to think out what this would look like. I guess no time like the present. All right, so what might that look like? So we could say like I don't know, WebRTC new. Right? Maybe it returns back something like this. I guess we would want to pass in some sort of config, right? And the config might be the server, the turn server, and the stun server, right? What else would it need? It would probably need like our ID. And this is not the order we would have these things in. This is just sort of us like exploring what this API might actually look like. Okay, so at this point though, we would have some sort of WebRTC thing. We would assume that it's doing the signaling and all of that. However, we would somehow need to connect. So this is an input, so we would somehow need to pass it our audio and video pipelines to link, right? And then on the output side, we would need to connect our audio and video pipelines to send, right? Then even bigger question is, can we somehow get our input and output to share the same WebRTC connection, right? This one's going to be a little more complicated. And I suppose the only way to be able to implement something like this would be to move the abstraction up, right? So rather than us creating the input, passing it a configuration that has all of the details we need to establish our WebRTC connection, we would need to create the WebRTC connection up top and then pass that down here. And if we did that, then we would, in theory, be able to say, hey, connect this to both the input and output. I have no clue how we're going to do that through the HTTP API yet. But if you were using the Rust library, you could do that. So that's probably where that should exist. Poncho, thanks for the follow. Yeah, so, I mean, I guess in theory we could have the HTTP API allow you to create WebRTC connections and then link those separately, where you could link them. Let's see. So the stream from Connect gives you a TLS stream, which you can send over a channel elsewhere, which would be the connected client. Yeah. So I mean, we could also, in theory, maintain an internal hash map of WebRTC connections based on the server and our ID. And I guess if you gave the input and the output the same ID, you could allow them to find each other. That would be another possibility, right? it would just be a function of what server am I connected to and my ID, right? And if these things were the same, it does create a problem though if you were to add more than one output and you use the same thing, but I suppose we could error on that. From an HTTP API perspective, that would probably be the most straightforward. The other option would be to like post to slash WebRTC or something where you specifically add them, and then when you add your input, mixer foo inputs, right? You could hear right, so you could in theory do something like this, right? So I guess those would be the two ways to do that. I guess another way, so this would be option 1, split WebRTC connections out completely in the API, okay? Option 2 would be automatically share connection based on combination of server and our ID. So that would be option 2. Option 3 would be to, thinking this through here, option 3 would be to implement our GitHub issue where we actually want to have inputs and outputs have multiple connections. This would solve for us linking an input directly to an output, or linking would this still work? So this would allow us to have our input flow to multiple sinks. Okay, no, so option 3 doesn't work because wait a second, no it would, because then that would mean we could have an input flow directly split and send directly to a WebRTC. Okay. But that's still one direction. What are we doing with it? No, because it would serve also as an output. Yeah, so WebRTC is one of those unique ones where it's both a source and a sink. So we have to figure out where that fits in. So Ezra Flag, thanks for the follow. So loop let stream equals server next, out send stream, and elsewhere you're reading from that channel and doing processing on that stream. Yeah, so I have to figure out how we want to design this. Each one of these is kind of interesting in both its API surface as well as its like design choices. They each kind of come with complications. And really, it's our only bidirectional one. So maybe it's just implemented as its own unique element type that is meant to be bidirectional. And then the API server is allowed to create it as both an input and an output. I don't know whether I favor any of these over the other. I mean, the multiple connections thing would be useful, because then that would basically allow us to have all of this, like basically like a hash map. I don't know, string, I don't know, some element, right? It would allow us to have like a hash map of connections, right? And then in theory, we should be able to have a way of connecting one stream to another. And then maybe there's something that tells us whether it's a source or a sink, and we error on that. Who would have thought this would get so... Like, I knew that the implementation of the WebRTC stuff could get kind of challenging, because it's new to me. I don't understand how all that stuff works. We've learned a little bit tonight. I didn't think that I'd spend so much time refactoring and thinking about how the application itself needs to be designed around this, even outside of how we implement the WebRTC bits. I don't know if I like this. I think that if this were going to be a thing, I might as well go this route, right? I might as well make it generic enough where we're just creating an input and output, and then we're just like making connections between things. This could be a possibility. Right. I mean, we do need to figure out where to maintain this information, though, and I think that ownership is probably going to be a big issue here. Right. Because nothing I'm passing in here is going to allow me to do that, so I need to communicate with something somewhere. Kind of why I like the idea of like pushing this WebRTC thing up higher. I'm starting to think that this has been a really long day and a really long stream, and I can't wrap my head around this. Ownership is going to be a problem. Because we basically need this type that we're looking at right now. It needs it, at the very least, it needs access to the GStreamer elements, which is okay. Those are C, right? Like we can clone them. It's all using like G-object and stuff under the hood. But internally, is it going to need any information that's going to come across the WebSocket? That's starting to be my concern. I really do like the idea of having this abstraction where there's just this WebRTC input thing, but And we could create a shared library for both the input and output to call, but it's still going to be... I mean, that would probably be the simplest path forward. The only issue that we're going to end up having is that we can't share the connection for an input and an output. And I think for like our current use case, that probably doesn't matter so much, right? Because we have two use cases we're trying to solve here. One is like having a preview or multiple previews for the for like the producer, right? So we have like a producer window, probably one, I don't know. And then you could just switch between the cameras rather than having to have each one of these things connect and maintaining multiple WebRTC connections. I mean, we could do it, but maybe for now we just have one preview window. TLS stream can be split and or wrapped in an arc mutex. So you're basically saying if we teed the WebSocket, we could forward the messages? Okay, yeah, I could see that. But yeah, so right now we just have those two use cases where we want to patch an input through and we want to see what's on it. And, you know, even that may be its own use case altogether, right? Where we create a whole separate branch of the pipeline that is just, maybe it has its own mixer and compositor, right? And it's just always connected. On the other side is the output here. When I was using the async tungstenite stuff, I did split it and then wrapped the ends with channels. I mean, because we could create like a messaging system. I mean, I kind of want to solve it the right way. Like, I almost feel like... but yeah, Tokyo and others let you split a TCP stream. Okay. So, it's interesting because at first I'm saying I don't like the idea of managing WebSocket. I don't like the idea of managing WebRTC separately. But the more I think about it, it's also like... Wait, what are you doing? Interesting. There we go. Weird. Web. What is going on with Excalibur here? All right, Web RTC. Okay. So I'm starting to think about it and I'm wondering, like, does it actually make sense for this to be managed separately, right? So we have the concept of the switcher, but in this particular case, like, we're talking about the switcher, but a switcher is really just something that holds multiple mixers, right? Well, effectively, this is almost the same thing, right? So does this get created separately? And then we tell it what its input is and what its output is. The same way we do a mixer. When we create a mixer, we attach inputs to it, we attach outputs to it. So now I'm starting to wonder whether, like, that is maybe the right way to go. And then if we added this whole multiple connection thing here, right, that would allow me to say, okay, well, this input should be connected to that mixer, but it should also be connected to this WebRTC. right? Or, you know, this mixer also should connect to this WebRTC on the output side. And the output of this WebRTC could come into the mixer, right? Generally, splitting read-write halves make it much easier to management. You have loop that reads, you have loop that writes, and you use the channel or whatever signal to loop through. Yeah, so I'm starting, because then this would allow the server to manage WebRTC up at a higher level than inputs and outputs, right? Because, I mean, even to some degree, a mixer could be an input for another mixer or an output from one, right? So the more I think about it, the more I'm kind of leaning towards this approach. All of this could be managed separately. Then it would allow you to spin up this WebRTC connection completely independently and then manage it and swap out the inputs, right? Because then you could, you know, remove this connection from here. Oh, I don't know where you're going. And then connect this one to it, right? For preview. And you basically just be signaling that. I'd highly suggest looking into Tokyo Select rather than Future Select. Okay, so this would in theory work, but we have to get this multiple connections thing down. We have to manage all of the connections that it has, I guess. And then I guess we would have to figure out, like, when it gets disconnected from here, we would still need... Well, no, because the mixer would just be a connection. So I think what we would end up doing, right, is in our link method, here we would probably need to maybe create like a connection type that manages the audio, the video, and the pipeline. Yeah, that's okay. I think this might be the way to go. I think that we end up having to do some refactoring of the way the normal system works, right? But where's our feature here? So we have this feature here, number 49. I think if we implement this, we're in a better place. Because then when we go to link, we'll just create a connection. We'll name the connection something. I guess we have to think about ownership though too. Who owns the connection? Who owns the connection? Source or sync? Right? Because somewhere is going to ask you to connect. So I guess it would be the caller, right? Who called link? They own it, I guess, and they're responsible for telling you when to unlink. Effectively, like, requesting a connection. Okay. It's funny, I think I've been streaming for 7 hours and I have not made much progress at all. We've done some brain teasing though. All right, it may be time for me to get something to eat. I have not eaten. I am starting to confuse myself. Should we find somebody to raid? Is anybody streaming? I'll be back on tomorrow though. I don't know, probably 12:30 Eastern time. I will be back on and we will work on this, and after a good meal and some sleep, I will hopefully have a better idea of how I want to do this. But I think that multiple connection thing is probably a good starting point. It kind of pulls me away from the WebRTC thing that I was wanting to do, but all right. There's not a lot of people on. We've got BJ Kegley making an MMO from scratch. I'm surprised you're not on, RW. Do we want to hit somebody small? Call you Grim. Oh, you're working on something you can't stream right now? I was like, you're almost always on. Yeah, and where's everybody else? Like, where's Strager and, you know, all the other nighttime streamers? Wow, there's actually not a lot of people streaming tonight. Period. All right. Let's get BJ Kegley. I don't think I've ever rated him. Oh, yeah. I did not consider that. Well, thanks for hanging out, everybody. It's been a long stream, 7 hours today. But I'll be back on tomorrow to work on all of this stuff and start doing even more refactoring so that we can get WebRTC working. Thanks, everybody. See you tomorrow.